travel for a while. I don't mind. I think my Windows. That's a win. Yeah. All right, we're live. What is up, Chad? Happy Wednesday. I don't know if some of you were just watching the Brain Bites podcast, but that's where I was. That podcast is our Twitch Teams podcast, and it's on every other Wednesday. So I was just watching. I was not on today, but I was definitely watching and hanging out in chat. Hope you guys are having a wonderful Wednesday. For people in Europe, like you're already done with your workday or whatever, so that's kind of awesome. Otherwise, you're probably, if you're watching this at work, you also rock. All right, so let's get started. Let's not let's not exaggerate here with the introduction. Doggo's in position. I'm in position. Let's bring you guys over here, all right? Let's go. And yeah, I've been working a little bit, like outside of the stream, just a little bit on our edge case. Ever since then, ever since yesterday, I've been a little curious about how I can tackle this. Wednesday's almost over. I'm sorry, still technically accurate. All right, let's bring you guys over here. What is up? Good day. Good day. Good day. Good day. I'm waking up still. It's I'm snowed in today. Like it's one of those days. Not high energy today. All right, cool. All right. So the edge case. Let's start let's give the intro. I'm sure people that are here right now they kind of know what's going on. We'll reintroduce the project a little later on for people that might just be joining. And if you are just joining, do not hesitate to ask for clarification. But there was an edge case yesterday. I can show you the level or the type of level that was causing some issues with our thresholding. For the most part, we have a working reward function that can kind of run in real time when we're playing the game. But levels like this that have this very, very, very light backdrop or background, they were interfering a bit with the thresholding. Right, so it's not necessarily let's say it's not necessarily the lightness of it all, but more the fact that it's pretty much like all the RGB values are in the same range and pretty much the same values. It's kind of like a whitish color, so very, very light and the same RGB color. So that would pass our test for the thresholding of the score, right? And so for the most part, our thresholding was working fine, and then we based the reward function on that. But then we came across this level, and all our values were off, they were totally off. So that was the latest problem. We kind of stopped there yesterday. So I could run it. I could run it and show you guys, like how the thresholding and rewarding function works. But I was really, really busy in the meantime trying to find a way to mitigate that sort of problem, right? Wow, new game, nice shirt. You know what that is? You know what that is? Anyone know what this is? I can don't try too hard. Don't try too hard. It's not that special, but it is sort of on message. Sort of. Yeah. Try it. Someone try it. I showed it. Showed the logo and Bob's, all right. Captain America logo. All right, maybe try a little more than that. I'm just saying. Maybe just a little more trying. It's a shirt. Serpent. Yay! Well, someone's on the right track. It is a shirt, that's for sure. It is a shirt. Okay, no one's obviously gonna get it, but it's actually the Anaconda logo, right? So of course that's I'm wearing free conference T-shirts because that's just the type of person I am. So that is an Anaconda T-shirt. Really. Now I could turn around and show you in the back that it says Anaconda, but you're just gonna have to trust me. I don't want to do too many physical maneuvers here. Probably not. I haven't had enough coffee for that yet. So let's go and well, I could illustrate the problem. I think I got rid of my samples though. But that's still gonna do. If I open this one, it kind of brings up a situation like that. Anaconda. Yep. Crop top. Oh no. And this is what happens. Okay, so if there is scoring, it gets lost among this thing here because some areas are passing the threshold. Why are they rectangles like that? Because I was kind of on the track of filling up the bounding boxes. Like in reality, it would be more like objects. I don't know if I kept a frame. Yeah, something like this would happen. I don't know if it's very visible or not for you guys, but see, I would catch a multiplier, I would catch the score, but then we get these other little regions in the image that would get caught by the thresholding, right? So this is the thresholded image. When I say thresholding, like I said, what stupid Windows shortcut that is. God damn it! And then you can't undo it. Oh yeah, you can, but whoa, rip OS. Okay, let's never do that again. All right. The only cool shirt I have is one with the Navi logo. Damn. Where's the merch? There was merch at one point, and I don't think it no one ever got anything, so I just decided to fold that. uh, uh, nice resolution. Exactly. It is. It is. What do you guys see when you see this? Like, never mind the numbers. Like, what do you see here? Yeah. I can turn that off. I probably will. I just don't work enough on Windows, but I have this bad habit of wiggling Windows. When I want to say like it's here, I just like wiggle the window and then it triggers the shortcut in Windows. I have to be careful with that. Right. So that's it. Right. So normally I would kind of like base my scoring based on these structures here, but since these guys show up, it kind of fucks up everything. So something that should not be scoring starts scoring a little bit more. But that's really like an edge case. But there's a way to get around that. So what I was thinking is like, okay, so what's really common with these things? First, I wanted to know like, is it like really like the entire thing that like kind of counts in the entire frame? Because I was like, if it touches the border, then I can apply some border clearing or something like that. But it does not, right? It's centered around. So I don't know if there's a vignetting effect, perhaps. I think there is, right? So the corners are a little darker and it gets a little lighter. There's a bit of a filter applied, post processing applied like that. So the area that kind of like is problematic is centered around the middle point of the frame, right? Uh, Turning off features in Windows. Yeah, no, I'm not gonna turn them live. Okay, so I'm gonna try not to. I'm gonna resist the urge to wiggle the windows for today, and that's I'm gonna do that. Right. So I'm looking for ways to remove this, and I was thinking, like what's a nice way? Well, we could do like the same old school object detection that we were doing, right? Because we already have a thresholded thing. So if we label these and extract bounding boxes out of the detected regions, we could analyze the regions and perhaps like do something. So there's all sorts of properties that I have access to, like area. I have access to the area. I can kind of count how many pixels are in that bounding box compared to the rest of the image. I can also count like the white and black pixels and kind of like establish something based on that. And I was kind of like in the middle of that, and I didn't really solve it or anything, but I think I'm on the right track with this thing. So if you start seeing me work with this here, right? So yeah, let's say this is the death screen, and you guys will recognize it probably, right? Resizing and encrypting. Why would you do that? God damn it, dude. That's so risky. So yeah, you'll notice that it actually, I'm the one that does that, by the way, right? Like just filling it like the entire rectangular bounding box with white pixels if they match my actual logic. And I'm looking to have this work in a case where it's the score. So this is getting good, right? So this is the multiplier, this is the score, and then I have some garbage I need to clear out. And I was kind of working on clearing out the little garbage detection. That's kind of like what I was working offline on. But I'm afraid that this is not going to be enough because there's still a situation that where we get the awesome and the great that would be problematic. Now keep in mind that what we have right now, if I undo what I did overnight and I use exactly what we had, it would still be good for like 95% plus of the levels. It's just that we found an edge case level where because it kind of seems like the atmosphere / background is a bit of a random color, and if it happens to be, well, I guess like all colors at once and be something like white, then it clashes with our thresholding, right? Like clause. So I'm just trying to address this edge case because I think the approach that we have for scoring and is still very good, is still fast enough. I don't want to go too far from that. Now, if you're confused a bit with what I'm saying or what I'm doing or why I'm even looking at images like this, I am performing some operations on the raw images that I'm getting from the game, and I'm looking to isolate some specific components, right? So I'm looking to threshold. I'm looking to remove, if there's a logical way for me to remove garbage I don't care about from the complex frame and just like keep the parts that I'm interested in. Because once I have all the parts I'm interested in, I can base off some other calculations based on that. Yeah. No, I'm building the reward function from that for our agent Vilsal. That's what I'm doing. Right. So but we have this edge case with this specific level right now. Other levels I didn't have a problem. I even showed and tested yesterday that like the reward was working fine, and for the most part we were all like pog champing and stuff. It was pretty good. But then we encountered this level. It was just like it was kind of a punch in the gut. Um, and we had just seen like the rocket launch on top of that, so I was just like, you know what, like this, the rocket launch is pretty awesome. This is kind of sucks. I'm just gonna I'm just gonna stop and try to sleep on it or something. Uh, so let's show you in the game when I'm trying to isolate. I think it's pretty easy. The death screen doesn't matter. Now, when you're in the game and you play, you're accumulating score. Sometimes it's hard to see against the background. That's the whole point of the thresholding, is that we're able to see it nonetheless. Right? So the closer you fly, you kind of accumulate a combo, and if you keep the score going up for a while, you'll get a multiplier. And then in order for that to get in order for you to get your score, you have to kind of stop scoring points without crashing, and then it'll commit your score that you just accumulated in the combo. So the parts that I'm interested in are obviously like finding the score at any point in time, being able to tell if there's a score going on. I'm interested in finding if there's a combo going on, and I'm also interested in certain events and they're kind of hard to get because you have to play well. But there's events where you'll get like an awesome or something like that when you fly in to like smaller, like this. You just barely saw it, and I'm also trying to make that part of what I'm thresholding. So for the most part, we're lucky because it's a pretty opaque white-ish font against backgrounds that are never like really pure white. So I can kind of threshold based on the colors, and that's pretty much it, right? And that is it. But I'm still fighting against a level like this one. Now, just for comparison, if I were to use another map, right, just to show you another map, like see map like this, no problem, right? It's really that very very bright whitish background that's causing some issues with the thresholding. So even if the contrast is a little clashing, maybe this is not the best level. There are other levels that where it clashes quite a bit. It's not a problem. It's not a problem, right? Because the values, not only do they need to be high in that UNT8 range, so like 250 and up or something like that, and they have to also be above 250 for all the RGB values, right? So in some cases you'll get a very very light color, but it's going to be, they're not going to be all above 250 because there's some tinting going on or something. So it's really just when it gets and even this right now is fine. Like if I were to score against a background like this, it would not be a problem, right? Yeah. Just use yeah, okay, just use yeah, sure. Just use that, and no one has made like a viable. There are demos on how to use it. No one's made a viable demo on see, that's never going to be a problem on how to exploit Spectre like in a normal consumer application where it doesn't require all sorts of awesome. Was just right there, right? Hola Snekor, hola. What's up, Lottie? Okay, so let's go. Let's do this. Let's do this. So I'm gonna go back. We did save the map because they're all like random maps, but I did save the maps. There are two maps that we detected were causing issues, so we saved them. And I'm just working with thresholding right now, so I'm trying a bunch of things. So you'll get to see like my process. I'm really, it's almost like science at this point. It's a bit of an experiment. I'm gonna be formulating some sort of hypothesis and just like trying to invalidate and react to what I see in return, what I get. So I'm measuring some stuff in my experiment, and then I can see like, hey, do we want to go like towards this more, or just let's ditch this approach and do something else. So my goal is to remove the false positives, right? So in here, there's a good chance that this is a multiplier, this is a multiplier. The score is kind of like behind here, and these guys are just like false positives. They are. This is Doggo dead. That's the common undead. You want to see? You want to check on Doggo for a second? I can always like do that. Just give me a sec. Whoop. Oh, she's fine. She's fine. She's just just enjoying the day, you know. Just like having little sleep twitches. She's fine. All right, and then this is exactly a case that I'm trying to get rid of. All right, so it's not exactly easy. It requires a bit of creativity, like a bit of like like you have to. It has nothing to do with programming. Like I said, I was kind of saying that yesterday too. Like at this point, this is like pure problem solving. It has nothing to do with your programming or image processing ability. It has to do with like coming up with ways of removing this. So you look at like the actual attributes of what you see on the screen here, and you have to find a way to filter out the unwanted stuff. So that's why I was going for, of course, the regions that have larger areas, the contiguous regions of white pixels that have bigger areas. They're not very likely to be text, right? And text is score, and qualifiers like awesome and so close. So that was my first, not my first go at this. It's a Pagale. Yeah. So what I was doing, let me show you what I was doing. Let me be super transparent with the process here, right? I was going for like doing the same threshold thing, of course, and I was just saving some frames with applying by applying some sort of like modifications, and just trying to see like what's left and if I'm doing a good job or not, right? What's up, dog? Is that what you were going for? Or are you just replying to Bill's song? All right, let's go, man. So the logic right now, all I'm saying is like the usual thresholding. So every RGB value needs to be above 250, right? That's the one thing. That's number one. And then I will do the old school object detection. So that is finding the contiguous the bounding box around contiguous white pixel areas on that thresholded black and white image. And I will get bounding boxes back for this. Then I can kind of like play with a few things like the area and the composition or the ratio of white and black pixels in that specific bounding box. So what we ended up doing, and I say we, the royal we, of course, me and Doggo. When I say we, and you're like, what the fuck? Just think it's like me and Doggo. Okay, we're a team. So we is me and Doggo. Okay, so we ended up doing that together. So what I'm doing is, first of all, like extracting, just unpacking the bounding box. Then I'm counting my white and black pixels, and I end up switching all the stuff inside of that bounding box to like black pixels if it's a larger area than some arbitrary value that I'm still testing, and if the ratio of white to black pixels is under 0.5. Right, so these are all like arbitrary values that we're trying to find like the sweet spot for. But that's essentially what I'm doing right now, and I'm just saving the frames. So I end up with the frames in here, and I can kind of see like, hey, are we getting closer to what I want or not at all, right? So there's still garbage here. See, this is not text, but it still got counted up as, so it's a visual artifact that I still need to get rid of. The small things, right, the little like small dots like that, particles or whatever, I can get rid of them pretty easily at this point. But it's still trying to figure out like why do I end up with this, for example? What is that, right? So maybe I still need some. I would probably need the reference frame along with that to be able to see like, hey, what was that thing? Right? Maybe just overlay them. Maybe I could just make this a specific color and overlay that thing on the original image, and that would be a start, right? I could kind of try to visualize what this is on the normal frame. Maybe that's better than the black and white threshold, because the problem is I still see like how many regions I have. I can kind of make up that this is the score, this is a multiplier, but I really have no idea what these things are, right? So I can, like I said, I can clear the small ones, but why am I clearing this? What's my justification here for clearing this? I don't know, because I don't have context. So I was about to do two things. I was about to use this image, or an image similar to this one, bring it in the notebook and start looking at like the properties of the multiplier, and say like, okay, how many white pixels, like what's the size of the bounding box for the multiplier, because it doesn't really scale, it's always the same thing. So I was like, maybe we can expect this static amount of pixel or a steady bounding box, and I was also going to experiment to try to get rid of these things right here, right? But the other thing that we could do is what I just said, is also we could take this and apply it as a mask over the original image, and try to visualize like which parts, what in that image that is. So I don't know what I want to do first here, but we have to get started. Because once I have a solid reward function and we handle the edge case that we found, at least there might be other edge cases that pop up later. Then we can start working on implementing like the machine learning stuff, and that's going to be fun. Also pretty hardcore, but we'll get there. So let's get in the notebook. Let's try to find a suitable frame for this. one that has probably like a multiplier. In a perfect world, I would also capture a frame that has an awesome or a so close. And I think I'll try to do that because that's going to give me all the information. I'm going to get rid of all my samples here. I'm just going to do a little bit of capturing for a sec. Try to get what I want out of this. I need to go back to the map that was causing, like the edge cases. This one. And I'll do Serpent.AI super fight with my game agent. And my goal is to, while this is recording, nice Vilsal. I don't know why I'm getting the big picture notifications right now. I don't know why. I don't know why Steam started to default to that. Okay, so let's say it's starting to record and it's applying the filtering or the threshold thing that I'm talking about. Now I need to not only have, I need to get a so close or an awesome, which is not easy. And it's kind of a good point to think about because you will have to do very game specific stuff for your reward functions. We've had a discussion about that before, right? So that's pretty much why we don't have AGIs at this point, is because we can't have the AI determine by itself if this is a good thing or a bad thing, and we have to manually implement some rewards and some punishments, right? It's not able to infer that was a good thing or a bad thing that happened, and that's one of the biggest obstacles, like with the current tech at least. Maybe we'll change our mind about how we want to implement these things in the future, but as long as we have to tell an agent that in this specific case this is good or this is bad, we're not even close, right? We're not even close to getting general purpose or like AI AGIs. And you can kind of see behind my terminal right now that it is populating like the directory with the images. So that's my goal. I don't know why I'm crashing here. Still trying to get like a nice, clear, awesome. I did get it so close. I don't know if it caught it because it didn't really last very long. Oh, there you go. So close. No multiplier, but we can probably live with that. Okay. Let's stop it. Let's stop it. Yeah. All right. Okay. Where? This one. There you go. That's my so close. You can kind of almost tell. If you know that that's what it is. No, that's not a terminal emulator. That is the Windows 10 terminal. There's no emulator, Puka. It really is. Are you saying that because of the transparency? Because you can totally control the transparency in a Windows terminal now, on Windows 10 at least. All right, so there it is. Of course, like Windows is gonna do Windows things like not show me the exact image and add its toolbar on top of my image. Yeah, no, it does support transparency. Yeah, look at that. You can just go here, properties, colors, opacity, right there. Right. Not a big not a big deal, but kind of helps. So there's my so close. Why do I want that? Because I want to calculate the areas of these things, right? Because I want to come up with some rules to filter out, artifacts. And if you think that, hey, you're good, like you have your score and so close, you're good. No, we're not good, because that was probably performed against, like, the white background was not there. If we look at the pictures that got collected, you can clearly see that we still have some artifacts in some cases, right? So my rules are not like, they're not there just yet. They're just not there. So there's two possibilities. I remove what I did in terms of processing, and I save the frames. I just thought of that. I could save the frames with actually the actual artifacts post thresholding with the 250 values for all the RGB values, and work with that in the notebook to try to come up with something rather universal to clean it up. Because the problem is, if I bring this now, I could get some measurements on what's the score, but I don't think I'm going to come up with some logic to remove these guys. Like, that's probably, yeah. Rules are for losers. Yeah. In this case, they will help us, however, like just a little bit. All right, just for an edge case. But see, this is typically what we would see. This is a perfect example of something that's super clean, right? I would get something like this, and I would get something like this, and then we can kind of say, hey, it's the score plus some sort of like bonus, right? Because it's so clear that it's this. We can reward based on that. Where it gets complicated is when my what I'm getting is something like, you know, like this. Then I can't really, like, I don't even see the score here. I don't even know if we're scoring. Probably not. We're probably not scoring. Now, what's the problem with that is that I would probably think that we are, because there's some level of you know, like white pixels in there that make me think that we are scoring. So I would reward the agent while it's doing something that doesn't deserve a reward. That's why it's so important, right? So I did say yesterday to not obsess over reward functions, but you have to make sure that like that it actually returns like decent stuff. Like when I meant like don't obsess over reward functions, what I mean is like don't invent like 15,000 like tiers of rewards, but you have to make sure that it's at least giving some signal that is proper, right? If you're punishing for something that's good, or you're rewarding something that's bad, don't be surprised if it doesn't work in the end. All right. Okay, so let me remove. I just thought of that. I think it's the best way. I know we just captured this, but let me remove the processing, and we'll try to come up with some sort of like set of rules, some logic, based on like typical frames that have like a score, a multiplier, and some bonus. Just to know, right? Rewards the agent for doing the wrong things. Well, we could always make a shit play, like shit player agent. That's definitely something that's possible. Okay, so let's remove like the processing itself. Well, we'll still save the frame, but everything outside of thresholding, I'll comment out, and then I'll do the same thing. I'll start the game again with this current handler. Like this. Start playing, and then we're still going to collect frames, but this time it's going to be like, you'll see what I mean by artifacts. I showed you guys a processed version. Now you'll get to see the actual problematic frames, or whatever I get here, where it's just not the score, the bonus, and the multiplier, but there's a lot of noise and garbage in there. Okay, so eventually it's going to start. That was not so close. That was too close. All right, so I do need a multiplier. I do need a too close, so close, whatever. So if I can find a spot on the map where I can kind of be guaranteed to get it, that would be kind of useful. All right. Yeah, I totally ditched the OCR. I wanted to show that OCR was a possibility with the framework, but I also showed the next day, showed some benchmarks on it, and then. It's pretty obvious that you can do it, right? So OCR will do a good job, will give me, you know, like the actual reading of the score, but it will take like 300 milliseconds, which is not acceptable. And before people cry about like, oh, try without Python, it's not even with Python, right? I'm just using Tesseract from the command line, essentially, and it still takes all that time, because OCR software was never mandated to be quick. It had to be quick enough, but not to be fast per se, right? That was not the goal. It was to have some sort of degree of accuracy. That was always the goal with OCR stuff, right? So I think I got a couple of so closes there. Might be enough input data here. So what I did instead is just like with the thresholding, we can kind of isolate the score. In most cases, because I'm working out an edge case right now, but in most cases we can isolate the score and the other qualifiers like a multiplier or bonus from whatever background and base the scoring on that. So I can punish a little if you're not scoring. Some people took offense to that yesterday, but I have to explain that if I don't punish enough for not scoring, the agent will find a sweet spot where it's comfortable in not scoring, because they think, hey, I don't get punished too bad, and if I try to score and then die, it's probably worse than just like hovering around and not doing nothing. So I have to punish. Not scoring, and then as you start scoring, you get some sort of like positive score. If you get a multiplier, it kind of increases a bit, and if you get a bonus, it gives you like the max score, right? I think that's gonna be enough. It's probably way more than enough. I've been talking. Let's just like zoom out of there. Okay, there you go. So that's the actual problematic, and this is where I came up with my vignette thing, right? Now this is the real problematic input. So in this specific level, it does that. If I were to try like the same code against a different level, that's not an edge case level, it wouldn't give me this. It would just give me like the score and the so close and everything like that. But in this specific level, we get, and this is where my my vignette thing, like vignette like thing is coming from here, because you can kind of imagine that it's darker in the corners and it gets lighter, right? Just the vignetting effect in general. And as I get to this area here, it's finally bright enough, right? Because there's the absence of the vignette effect that it would get pulled up by my thresholding. So this is a case where I'm not scoring at all, but look at all this input technically, right? And how can I tell that this is not like score? So we have to clean this up. This is not a perfect frame to work with, however. I'm gonna need a frame that has both garbage and good stuff to be okay with all this. So maybe you can just like peruse them. I can just start with this guy and then eventually we'll find out. So see, score. This is what the thresholding normally does. It's able to isolate the score from anything. But in this case, we have some trash that I need to filter out without filtering out this, right? So it's really important to keep the valuable part and remove the bigger part. So of course, like my logic was just like, hey, if it's big enough, right, get rid of it. And it might be your logic, what your logic tells you too, because you see this frame here. But there is an edge case where the score is contained within the large object. The large object will still have like a big bounding box around it, and then it will blank out the entire big thing, and then it would take away the score with it. And I try to also mitigate that by ordering before I do this, like ordering from big object to small object, but it's still not perfect. All right, so edge cases I do expect to work. I spend a bunch of time with them. We could keep this frame around just because it's a simple case of a score and some garbage, and they're separated. We could do that. And see, this is kind of fine, but there's that thing here. And this one would be hard, man. This one I can probably not get rid of. I don't think I can get rid of this thing because it is small. Unless you guys like have some sort of magical logic that I'm interested in hearing, of course. But this is really, really small. And it's kind of like the same size as a character that we're isolating. So this, I don't think I could get away with. I don't think so. I don't think there's a way for me to get like rid of something like this. But maybe it's not the end of the world. If it's just this, yeah. Would comparing similarity be an option? Probably too slow because I have to do it. Shit, we're still doing it on every frame. Well, in this case, it's not an option. I don't want to make sure it looks like a digit. I don't think it's necessary. I'm still of the opinion that I can filter out the trash. The magician never tells its tricks. See, this is all trash. Like, this deserves a penalty, but it's going to be really hard to say, like, hey, for sure there's no score in there. It's going to be tough. It's going to be tough. So we need to analyze, like, and I'm still looking for a frame that has, like, a bit of everything. Some trash, some score, some multiplier, some bonus. See, this is my edge case that I was telling you guys, right? Pixel width? Yeah, but can we really... It's not a bad idea. It's not a bad idea, but can we really rely on this? Like, 100%. Like, without a doubt. That's the thing, and we will analyze them like that to make sure that, hey, maybe it's the right way to do it. But this is my edge case that I was talking about, right? It's possible that the score is included in a larger object, and then it gets really hard to filter out the object without touching the score. What's up, Mike Sai? The numbers are not that wide, yeah, but there's other stuff, and see, this is the same case here. Same, and this is our player. We can even see it. I'm trying to find the awesome or the so close. I know it was there at some point. It's a bit of a challenge. You'll have to trust me on that. Like, this sort of this sort of cleanup job is not exactly easy. Because we're humans. Remember that. I'm able to say, hey, this is a relevant part, and the rest is trash. But like, to a computer, it's just a bunch of structures, right? If the AI detects a massive fucking white circle, Just like skip it. Well, we were talking about that Dill Pickaxe yesterday too, right? We were saying, hey, maybe we could just skip the level, but there's a part of me that feels like this is, I don't have to do that. And I was saying, like, if we try a lot and we're desperate and it doesn't work, maybe we can just like skip a level if I get a lot of these frames. But yeah, just check when the player spawns. Yeah, I know, but this is not just like a reward function. This is me altering the behavior in the game based on something that I decide that's third party. It's almost like saying, oh wait, the AI works, but in this specific level, like I want you to skip it. No, I'm not telling you. Just skip it. Just trust me. Okay. It totally works, but just not that one. Not that one. Just use another. I don't like that. I don't think it's. I don't think it's honest, right? I don't think it's honest. If we wanted to get it to work, yeah, sure. But there's a part of me that if we can avoid it, I don't want to. Yeah, exactly, Shots. Like I didn't really like. I started trying some stuff. I started saving some frames because I was like, hey, if we were to take a decision to fix this, I need to visualize what I'm getting when I threshold. And this is an example of what I get. So you see the score is there. We definitely don't miss the score, but we also get a lot of garbage in the middle, around the middle. So I'm still looking for, see the multipliers here, scores here. That might be a good frame. Might be a good frame to work with. Because there is the multiplier, the score, and some garbage. So maybe, what is that? I don't know if there's a way in Windows to get, oh shit. No, it doesn't tell you on which one. So that's like 529105. God damn it, dude. How do I find this? Is it something like this? 529105. Okay, I got it. All right, so I'm gonna copy this and drop it here. So that's a good sample right there. All right. Omega lol. Yeah, man, I don't know. Okay, so now I need to find one that also has the so close or the awesome. I'm just gonna keep going. There's definitely a way to filter it out. That's it's almost like a challenge accepted type of situation. It's like a hold my beer. I'll manage to filter this out. I'm telling you, I'll manage. I'll do it. Yeah, there's always a shadow around the characters. No, I know, but it's like, don't forget that there's a lot of stuff that's been done already to get to that specific place. Okay, not count the white pixels and yeah, no, but that's okay. So that's good. You can write it in chat, but I'm not there yet. But yes, this is definitely the start. Like once I have my test frames, this is exactly the logic we'll try to go for. All right. I'm still looking for that so close. It's gonna be there at some point. There you go. So close. Garbage score. Might be a decent frame to work with. Let me say. I'm just gonna try to see if there's a better one potentially. I like that one. I like that one. I think that one's a perfect challenge. This one is perfect, man. Yeah, this one is perfect. This is the ultimate test, chat. If we can isolate the score and keep the so close and get rid of this big garbage thing, that's going to be a perfect, we're going to know where our edge case is probably resolved, right? So let's keep this one to 133, 609. Of course, I'm not going to remember those digits, but it has so close, I can kind of cheat there. It's this one. I know, it's this one. Yeah. All right, perfect. Now we have 2 frames. We are gonna go to the notebook and we're gonna start trying some shit. And this is where I want you to bring your logic, right? You don't check it at the door. You have to bring it in, and we're gonna have to try to be clever enough to figure out a way to remove this object and well, all that's not numbers and digits from that input. Okay. So let's bring this in. Let's say. Do frame A and frame B. Oops, there's no dot. Okay. Windows. Jesus. You guys didn't get the like friggin' like crazy sound in your ears. Windows was definitely not happy with me not having an extension on the file. Let's get to work. Yeah, for real. All right, so notebook. I'm pretty sure I have, yeah, there you go. All right, so we have a notebook here. I'm going to zoom in for you guys. I always zoom out after because I can't stand it. Uh, I'm old, but not that old yet. Like it's not the. Let's just say that I don't need to do I don't need to do this. I don't need to do this. Okay, not yet, not yet. Do we want to clear it out? Is there anything valuable that's here? Well, maybe the imports and the frame stuff. Yeah. Yeah, let's remove all this. Fuck! No! Alright, I guess the frame is gone too, so we're gonna have to... It's over. There's no control Z here. So let's bring in the... let's just write a way to bring in the frame. So it's gonna be SK image, IO, im, read. File path. That's gonna be data sets. No, just in data sets. Just in data sets. And then I have frame A or B. Alright, so let's start with frame A. Bring that in, and I'm gonna say as gray. Because it is a black and white image. So it's gonna do, we're gonna do this, and then we can try to skimage.io.in show, just to make sure or visualize the problem space that we're working with. All right, and then we can get to work. Oh, and I didn't run this, I think, because otherwise it would show this. There we go. All right, so first case. All right, it looks a little like this. Let's keep a full screen version around. Because this is just a plot that's an approximation. It's not a real image display. So let's also keep the full res as a reference, because we might need to go and look at that. So let's look at this for now. I almost did the wiggle thing again. Thankfully, it did not register. Okay, so how can we like just looking at this? We have to use our logic. All right, it's not programming. It's just logic. It's just problem solving. How do I get rid of the garbage here and keep my digits? Right. And now's the time to give your suggestions. Now's the time to give the suggestions if you have any. And we're gonna think about it. So of course, like large objects, I was gonna say it's probably easy to detect a bounding box, and I kind of had done some work there. But if we go to the next one, I'll give you the edge case of the large object right away. You have to be careful because you can have nested bounding boxes in your object detection. So see, we have like a bounding box around the 4 here, but it's contained in a much larger object, technically. So I can't just like black out big objects over a certain area, because I risk also blacking out my actual input. So you have to be careful with that. Yeah. Count how many objects you have found. I don't know. Is that really like input? Ignore everything too big and small. Okay, but you guys realize that I just show you an edge case here, right? I can't just say like ignore this bounding box because bye score. Right, score is gone if I do that. So we could detect nested objects, but that's additional logic that might take like too much execution time. So you have to be careful. And if you say count how many objects and start from that, so what would be the next step if you were to take that approach? Because I don't think I'm not saying like scrap that, but if I know what sort of signal am I going to get from counting objects, right? I say get some tea. Count the number of white pixels on a continuous space. Discount any that have too many pixels, okay? Or too few. Okay, but you still realize that we're working with bounding boxes, and that would get rid of of what I said here, like the problem, because there's a reason why I picked this guy. I picked this guy because it's a perfect issue, that the perfect like case that illustrates that I can't just like detect the big objects bounding box and clear it out, because I might have some valuable information within. These are not just rectangles that we're dealing with, right? Not bounding boxes. That does not really like no, it does. You can't really. Well, you can get a mask, but no, that's gonna be expensive, man. No, if you guys say forget bounding boxes, it's gonna get expensive real quick. Like we could always get a mask easily based on the actual image here, but how do you detect that continuity? Like if it's not a bounding box, right? Can you repeat what the problem is? Well, yes, I want to remove everything that's trash, and this trash is not like in every level. It's just our edge case level, because I'm basing a lot of scoring based on the the quantity or the structure of the white pixels on our thresholded image on that white that white background edge case level, I'm getting additional stuff in the thresholded frame, like this and this, right? So now it skews off all of our calculation or all of our logic. So the task is to remove the trash, the noise, and keep the valuable information. So this is a sort of easy-ish frame, and this is a harder frame, right? Where we have nested information. No, I have to be. I realize what you guys are saying. I get it. But if you say remove bounding box, I did say like no programming and just like problem solving, but just forgetting bounding boxes, that's not gonna scale well. That's not gonna scale well. That's not gonna scale well. Just detect if it's a number or not. If not, delete it. That would be awesome if we could do that. But if I could do that, I would not have a problem. Let's just say that. All right, so it has to be from manipulation of the image or analyzing the composition of a frame like this. If I could tell already that it's a number, then I could then I probably would be able to clear it out anyways, right? There is something that's called there's image entropy that I remember that might be valuable here. I don't know how it's gonna work though, because there's other measurements. Like, let's bring scikit image in. There's an algo that detects numbers. Yeah, but the problem is also the speed. I don't have all the time in the world. I could use OCR and it would work, right? But I don't have time. It has to be something quick, right? If it's just flood fill, OpenCV. I'm not working with OpenCV. Let's get that out of the way. I'm not working with OpenCV. There's an easy way. We can do it. It's just a matter of getting the logic out. And I wanted to show you like one thing. Like I want to look at the measure stuff in the API here. Okay, so there's other stuff that we can look at, right? It's not just like the SSIM and stuff like that. Okay, so there's the peak signal. Okay, Shannon entropy. Okay, that's a little more like what I was going for. So entropy of an image might be a good indicator. So if there's low entropy, it's probably not a character. Is my thinking, my line of thinking, right? It's more likely to be like some sort of like fill. But then again, that might not be enough, because we did see a case where it kind of looked like a character. I say we start doing stuff. How about that? We just start doing stuff. And I think we need to work with this guy in particular, just because it's the harder one of the two. So let's work with this guy right here. Okay. I had a good start. I would say I had a good start. I may want to bring this back, because I was detecting all the regions. Right, I was detecting all the regions, and then I would order them by area. So I was going from the largest region to the smallest region. And what was the logic then? I think I stopped at that point. But there's definitely something we can do with this edge detector. And then what? Because even if I get edges, like what's the signal here? What's my way of telling? Like blobs that have more edges? How'd you work away to black and white? By using some just like thresholding on the RGB values, right? Because the scoring itself is generally stands out quite a bit, and it's really steady. It's a 252 RGB value, right? So I thresholded on that, but then in a specific case, in a specific level, it will catch some additional information, right? It will catch some additional information. And that's how I work. So we're kind of lucky in a sense that it's not that hard to detect the text and the score from the full frame. But it's still, we still have an edge case here where it seems to be the case. So if we get edges, maybe we could evaluate the edge the density. And if it's high edge density, we could kind of keep it. I don't know, something like that. I'm not against that one, man. I don't, well, yeah, no, edge density might be good. It's just hopefully it doesn't take it shouldn't take that long to perform on a black and white image, but edge density might be very good for characters. Uh, Edge detector deletes large fill objects. Yeah, because there's gonna be less edge density, right? That's it. So if I look at a local neighborhood, the higher the edge density, if the local neighborhood is rather big, the more chance that we have that it's an actual character. Because like characters will be like some sort of complex thing versus just like a fill. I can kind of see where like that this would work. At least for this scenario, that's the other problem. Like, is it gonna work with this? Because the edge density of like say, well, this stuff. Okay, let's get some work done. How about that? Let's start by that. Let's bring in like some basic bounding box. I'm still gonna work with bounding boxes, but then we're gonna do some analysis. Yeah, try and we'll see. Absolutely. We'll do some bounding boxes just to get the local region, and then we'll do some further analysis inside of that region, right? But nested regions are still a problem. Yeah. No, that's it. I combined the bounding boxes shots with the analysis, and that's how I filtered them out. Right? That's how I filtered them out. I combined the two. Right? So I have some bounding boxes around contiguous white pixel objects, and then I do inside of that I do the edged density, right? While I look up the edge density, and then we got something to work with, right? So each candidate gets its edge density established, and then we delete the ones that are under a certain threshold of edge density. I think that could work, but we still have the nested. Just have to be careful still with the nested stuff, right? Because I don't want to get rid of. And instead of deleting, I just thought that we could, hey, maybe we could just like start from a black canvas and add the regions that fill this. Yeah, sliding window thingy sort of stuff. Yeah, like local neighborhood. Yeah, absolutely. Yeah, so we'll just like at a specific like neighborhood and look at the edge density. Yeah, it's not a table; it's a bench. But yeah, Doggo kind of took the permission there, Puka. It's not. I didn't give permission for that. It kind of happened, and then try to teach Doggo not to do it again. It's a bit complicated. She's like, oh, I'm allowed to do that. Well, fine. There you go. I'm gonna do it now. Okay, so let's get all the candidates. That's not even too hard. Okay, you can. Let's not even use my code. I can show you something that's more visual. That's even more fun. In their examples, the gallery, there is something for object detection, label image regions. Okay, so we can kind of leverage this a bit. M patches, I think I'm gonna need. Oh, you know what we can do? Just bring the entire example in because we have all the modules for that. And we're going to replace, of course, like this with our actual image. So you guys can see the bounding boxes that it finds, right? Doggo or Pythons? Doggo. Doggo's going to win. Doggo will win. Yeah, okay, so let's bring this in as a, whoop. And that's what's kind of cool about the notebook. You can't say that this isn't cool. I can just like grab this thing and whoop, there we go. We got this thing working. So let's tweak this to use our frame instead, right? Instead of that, let's use our frame. It's actually surprisingly easy. I don't even want to do clear border because it's extra operations I don't need. And then that's going to work on our black and white frame, or just our frame altogether, because it's already black and white. And this label image is going to be frame. I'm just trying to see like if I'm not messing up here. Hey, there we go. I mean, it's weird, but it sort of works. It sort of works. All right, so you can see that there's definitely some rectangles around each individual character, and we have some overlapping bounding boxes right here. And the job is to remove, of course, the stuff that doesn't match. So when I iterate over regions, right? So this area, like for region in this, I'm gonna get every one of these bounding boxes, and then I can apply like I can analyze what's inside. My only objection still at this point in time is the nested stuff, right? So what's the logic? What's the logic here? Well, maybe we could analyze every component, and if we use the edge density, some sort of measurement for the edge density, then we can decide to populate a totally black canvas, like I said. So essentially, like just an NP zeros that matches the shape, and whatever passes the requirement of the complexity will will get its content added. So I can still take the content of a bounding box and add it to that position. Okay, that's my approach. Okay, that's my approach. Let's go. Let's do it. So let's keep this around as a reference. I'm sorry if it's weird, but I have to actually problem solve here. It's not just like a show that's pre-scripted or anything. I have to actually problem solve this stuff. It's not always easy. Den binding box. Do the cat? No, they don't. They never overlap, and we've tested that cooking. So that's a good question, though. It's a good question, because if they start overlapping, it would still not, with the current approach I'm planning, it would still not necessarily be a problem. But it's definitely a good question. And in case if you're allowing me to blow your mind for a second, this is actually the player, in case you haven't noticed. Some people may have noticed, but this is actually the player. It's right there. And this is probably like some sort of column. Okay, so there's definitely a part that's relevant here. Have you used blur before? No, I don't want to do this. But why? But why? Ask. Like don't just ask. Like say why. Say why. Let's skip some the preliminaries here. Say why. Just say like if we blur this would be that what happens. Right? Let's not say have you blurred. No, I think I gotta. I know you guys are still going on about that. I think we have something that's gonna work. I think we have something that it can be a relevant box. But we're still getting the nested boxes, right? We're still getting them, so we can still treat them like on a case by case basis. So even if there's a really large box here and there's smaller boxes here, and there's a reason why these don't light up. It's just a region area, I think. Yeah, that's it. That's why we were missing these guys, right? So visually, like it's just smaller, but they are still there. But I treat them as individual boxes. I don't care that there's a nested box in this case. I'll just do the like maybe some canny edge, and then we can count the white pixels divided by the black pixels, and then we get some sort of ratio of the edges to area, and then we can establish a threshold based on that, and just remove. Just remove like whatever's under our threshold. I think it's gonna work. I'm just saying. I'm just hoping it's not gonna take too much time, because that would kind of suck. But let's start with that. So let's do the labeling. This is something you'll do so many times when you work with this. If you use a mix of black and white and blur, you should easily get removed anything that is very sharp originally. All right. Before going to black, so I would blur this. But blurring would just like change, affect the colors. I would argue that it does the opposite in this case. Not always. I'm not saying blurring is not a good way to do it, but in this case, the characters here, that the way I can threshold them out is because they are over a certain point in the RGB. If I blur them, then I lose this distinction. So this black and white image won't even happen. And I don't want to do edge detection on the entire thing or whatever, because that's bringing a lot of information I can filter out easily based on that. But just like, let's just have a bit of fate for a second. All right. Just have a bit of fate. I think we got it. I think we got something that's gonna work. Okay. Yeah. VR support in Godot Engine. Godot Engine is pretty cool, man. It's actually pretty nice. I would give it a try if I had to pick a game engine. Open source, pretty awesome. Let me just steal this and rename a couple of things. Like I said, this is a very, very common thing to do. I already have my threshold here, but you know, like we know how to reproduce this exact threshold. We have the code for it, so it's not a big problem. Label image. Well, let's just say label frame to be consistent in our little code here. And then the overlay, we don't need it. It's just a visualization, really. So I don't even need this right here. And the regions, I could say, plural. The regions are going to be region props on label frame. And then it's up to us, right, to decide what happens inside of there. And of course, you could combine that if you want to, but you know, like, let's keep it simple. Yeah. It already did. Yes, it did. It is out. It is out. 3.0 is out, Puko. All right, so label frame regions. Okay, so and then of course, like what happens is for region in regions. So every individual region, everything that you saw as a red rectangle is going to get analyzed individually, right? It's not going to be perfect, but it's going to be a good start for sure. Then we can figure out like if we're able to remove the smaller artifacts just as easily. Okay, do we want to sort them by? I don't think there's a need in this case, but we could technically sort them by area. I don't think there is a need for that. Let's apply some edge detection. Where's the API? You don't have an API link from here? That's kind of stupid. Is it feature? It is feature, I believe. No? Is it not feature? No, I guess it's filter then. There's, yeah, okay, there you go. You have your Sobels and where's the canny stuff? Just like easy feature. All right, it is in feature. And we can kind of work with this like right away and show you guys like what it looks like when you apply this thing. So can you not? That's not bright. You guys see Doggo like kind of almost like break your face on the floor? That was kind of lame. All right, we don't have feature. Let's just like import the entire world here. Why not? Never know what you're gonna need. Feature. Okay, so let's visualize like this, but with actual. Or we could do it one by one too. We could also do it one by one. And show all the candidates later. That's a possibility. Do you want to see like the? I can add a quick cell under there. Say like image dot io show, and on that we're going to use our frame, but we're going to use skimage dot feature dot canny on frame. We can kind of keep the defaults for now just to show how it sort of looks like. All right, so there are the edges, and I don't think it takes a lot of genius to notice that some areas have bigger densities, right, than others. So if I were to use on an im show, I could of course tell it a CMap. The problem is this thing, like I said, is a plot, right? So you don't see the full detail. I would have to save it. So you do this. what are we doing in 5 second catch up? We're just like trying to treat our edge case that we had, Jake. I don't know if you saw it yesterday. I don't remember. Could you put the? I could give you the frame if you want to, man. If you guys want the frame to try it out yourself, I could put it on like Imgur or something. Right? On the white levels, yes, absolutely. Right? So there are very, very few levels that have like a almost white distant background. And it fucks a bit with our thresholding to get the score and stuff like that. So I'm not interested in the score itself, but I'm interested in the presence of scores and bonuses, is what we should say. Are you guys interested? I could paste it up. I could give you guys this frame if you want to try some stuff on your end. That's always fun. It's definitely more fun than just like watching me probably not do what you have in mind, right? So get in there, and let's try to do some stuff, right? I could give you the frame. Just give me a sec. Okay. Where do I drop them though? That's my thing. Where do I drop the frames? I could drop them on S3 for now, I guess. I can make a little zip. Yeah, let's just like make an archive out of it. Can I zip this? Can you zip from Windows? Does it have like an archive? Am I blind? No, it does not, right? God damn. Alright, add to archive. Is Imgur fine? Because I'm thinking Imgur is gonna fuck and you know, like just add some more compression that might not give you a pure black and white image. I'm just afraid. I don't mind Imgur, like that's not my problem. I'm just thinking it might over compress it. Send to zip. Oh really, it's there. Interesting. Can I put images in a gist? I don't know, man. Probably. Send to, I'm just curious. Send to compressed folder. Nice. Okay, so you could do it that way too. If you guys are okay with Imgur, I'll do Imgur because it's way easier. I can just drag and drop and we'll be done, you know. So let's do. Okay, so I'm gonna put it on Imgur, but if you notice, like, make sure that you are working with an actual binary image, a black and white, pure black and white, not grayscale, okay? Because it might compress it a bit around the edges, and it might give you some pixels that are like grayish instead of black or white. So it's the easiest option for me to just drag and drop them, for sure. But just be aware. Just make sure you're working with an actual like binary image. Because there's no promise that this guy is not going to overcompress them. And there you go. All right, so it's in there. I have 2 images in the album. The 2 frames I'm working with. So anyone that wants to get their, you know, their hands in there, you're allowed to do so. You just get the images and you can kind of start like working on your own theories. Because otherwise, I know sometimes, you know, like you have this problem solved in your head and you're seeing me go a different way and it might bug you a little bit. So now at least we can get these antsy hands on something, right? All right, there we go. So that's our edge density. Well, that's an approximation. I could save this to disk, and we could look at it and see skate. That's the one. What's the last time you've seen skate spelled like that? skateimage.io.im save. I'm gonna give it a name. Really, doesn't matter which. So let's just say name.png and save this entire thing to disk. Did it not like it? Oh, because I kept the im show. Whoops. No, not if we. Whoops, and the CMap also doesn't belong there. There you go. Where's my name.png? Did it not work? Skate image, im save. Oh, it's not in datasets. That's why it saved it here. Parent. There it is. No? Is it because the edge brings it? I think the edge brings it back to float, And I need to take it back to like a UN for my PNG saving to work. I think that's what it is. Image as ubyte. There we go. And of course, this image viewer is a piece of shit, and it's always in the way. I don't know why they like. Who thought of that? Who's the the very brilliant person that thought that this was a good idea? I don't know, man. There you go. I can at least do it that way, right? So these are my actual edges. Now, if you pay attention to this, if I have a bounding box already because I did the object detection, and I look at, you know, like how many edges I have in there, or how many, so basically the white pixels within that area, I'm willing to bet that we can establish some sort of ratio, saying if the white pixel to black pixel ratio is around this, then we are likely to have a character versus just some other type of fill, right? Follow me so far? Because that's where we're going with this one so far, at least, until proven that it doesn't really work. Okay, so let's ditch this for a second. For every region, right? No, OCR is always okay. So the problem with OCR is that it's too slow. It doesn't matter what the size of the sample. It's just too slow. Like you run it from the terminal. It doesn't have to be like it's not a Python or whatever programming language like binding problem. OCR to just like start up the entire thing is just too slow. Too slow, too slow, too slow. Right? Never gonna work. I need to work in milliseconds. I can have like a 200 milliseconds and up delay. Because I'm doing this for every frame that I get in my agent. Not every frame in the game. Like let's calm down a bit. But every frame that I get in my agent, which is around like 4 FPS by default. Yeah, you can tweak it if your machine is able to, you know, like perform like that. But at around 4 FPS, so you have like wall to wall 250 milliseconds. So I can't do something that might take 250 milliseconds just to get me a character or a sequence, right? That's gonna take too long. It's gonna take too long. It's gonna utilize all of my budget, all of my frame budget. It's gonna go away for the OCR. So OCR is there because in some cases you are not dependent on performance, right? So let's say I'm dead and I want to analyze like the score. Maybe we'll do that today. If I'm dead and I want to analyze the score, then I can take whatever time I take. But if I'm in the game and it's kind of time sensitive, if I take like a second to do an operation, my player can't send inputs like in that duration. It becomes a bit of a problem. I can't block my agent like that, right? So that's why we have to, like, OCR is not bad. It would definitely work, and we've even had samples where it worked. It's just a question of performance, really. Okay. So let's close these guys. All right, for every region, we can extract, and I have that in my code. We could extract the bounding box to individual values. That's just going to be useful with NumPy notation. So let's start with that for sure. Like this, okay? And then we can extract the actual region, all right? So frame region, and just extract the relevant part. And then we can apply the transformation on that. The only thing I'm scared of is, no, it's going to make a copy, I think, if we use the canny. Yeah, it will. We're good. So frame region is going to be my frame, actual original frame, where the coordinates match NumPy's indexing methods, right? So this is why I can't use the bbox, like unless you want to write region.bbox everywhere. I'd rather just like extract the coordinates like that, and then we can kind of proceed like this. So this is going to be my region for every region that we detected. And then I can submit that region to the edges, right? So I can do the frame region edges, I guess. Stupid naming, man. Frame region edges. So as I came up with it, I was just like, this is so dumb. Like, frame region edges is going to be an SK image dot. Now what was it again? Feature, I think. Feature, yeah. Feature dot canny. And you don't really need to tweak the canny that much, just because, well, you saw what the defaults were giving us. Like when I showed you the edges, it's probably more than enough. And the candy is going to be performed on that frame region. That's going to give me an image that is using a float from 0 to 1 as its range for its values. I can probably work with that like right now. I'm not a big fan of that, however, no, because I think because of the flow precision thing, it's not going to fall like directly on a 1 or a 0. So I'd rather convert it back, because I know they do some sort of like estimation in there. So I'd rather convert it back. What's up, Dope? I'd rather convert it back. I am deep in some like image processing stuff, and I know I think it's not necessarily like the most interesting thing unless you really are passionate about this, but I kind of have to do this to move forward with the project. So SK image as you bait. All right, that's going to bring it back to the 0 to 255 range. So my white pixel is going to be 255. My black pixel is going to be 0. Okay, so now we have an array, and we could print that for now, just to show like the sort of domain that we're working with. Right? Look at that. See, some stuff like this. That's our domain that we're working with, right? Yeah, you trying to fix the pixel count thingy if doing the Misty level? Absolutely, 100%. Right, so it boils down to additional processing on the thresholded image. And I did give out some frames to chat, so because some people had some ideas, so I was like, you know what, let's just like upload the frames, and you guys can try to play with that too and try to get like the resolution in there. I do have my own approach that I'm trying out. This is going to be the best approach, who knows? But this is the data that I'm working with right now for every region, right? And if you've never really worked with images and code, you might like just be like, whoa, you know, like how do we? That seems like a big step from just like doing like web stuff or something. It's not really like it's just a bunch of matrices and multi-dimensional arrays in the end, right? It might seem like it's super complicated and everything, but it's not that complicated. You just have to start wrapping your head around these structures. That's it. As long as you can do that, like image processing is within, you know, like the realm of possibility. Don't be intimidated by that stuff, right? You find images, yeah, it is. Like, see, but it depends on what your background is, and that's it. And it really depends. Like they are, because essentially they're just like a matrix that has like n dimensions. That's it, and you just work with that. So they are rather straightforward. I'm just talking like for people that have different backgrounds, because I know from experience when I started working with images, I was a little intimidated, right? Because it's so different than what you're doing on the day to day. But in the end, they're just like structures like that. It's really not that bad. So you learn a few tricks to you know, like to bring them to certain representations, and from there you just do your regular logic, programmer logic. That's it. And like it's just like problem solving with different structures, right? So once I have this, we could extract once again the white pixel count and maybe like the total pixel count, and just make a ratio based on that. Is it? Yeah, it is a ratio. It is a ratio. You want your house to burn down from the roof or burn up from the ground? It's gonna burn up. Images, I think I agree with. And images are way more straightforward. They still have edge cases, as you can see. Like our problem with images can still bring some edge cases with, but that might just be my approach that causes them too, right? So I don't know. SVM, SVC from Scikit. I do have a bit of an SVM, but they had a problem classifying ones and seven. No, it's definitely not considered slow. To answer your question directly, it's something I would consider using on a frame by frame basis. Right, that would be fine. But I could not get it to distinguish, because I did it, right? And I could not get it to distinguish between the ones and the sevens. But that was me getting interested in digits versus, and I didn't have a class for garbage either, so it was probably not like the best SVM. All right, so the white pixel count, I already have a snippet in my existing code for this. Where are you at? Something like this, just with the right variables in there. All right, so that's NumPy notation. It's essentially gonna be me asking the size where my conditional or predicate whatever is true. Right, so I'm gonna say how many items or positions in that matrix like match this condition right here, and then give me the size of that. Right. So that's how I count the white pixels, because I know the white pixels are represented as 255. So I can just say whatever is 255, what's the size of that? How many items match this? Right, so I bring this in like this, and we are working with our frame region edges. Like this, dot size. And then we can establish a ratio. Let's do something here for fun. Hi. What's up? How we doing? What's up, Skylius? With a nice Sequisha mustache. I'm in the middle of doing some image processing stuff. So we're thresholding some game frames that I capture. I'm kind of treating an edge case. Because we're building an agent to play through, like self-learning, machine learning stuff. This game right here, right? So Super Flight, it's a 3D game where when you fly close to structures, you accumulate some scores. So first, you don't want to explode your face like this, because that's kind of bad. And I'm kind of fighting an edge case right now. So for the most part, I got my image processing done right and fast. But against this sort of level, I'm kind of collecting some extra image information. And then we're trying to just like apply further logic to clean up the thresholded frames. So this is an example. All right, so I'm mostly interested in like the bonus and the actual score, but the rest is noise. So we're having a lot of quote unquote fun, and I think a lot of people disconnect when it's that sort of work, but it needs to be done. It needs to be done. All right. It needs to be done. I can't skip the tough parts. We have to work with them. Okay, so where was I going with my? Okay, I don't know why there's. Oh yeah, I wanted to save the images. Train of thought. So I'm gonna say images or regions. We already have regions. Let's say images. Fuck it. List, and also the ratio. All right, so the ratios. The reason I'm keeping them as separate lists is because I want to try to use show image collection at the end to show all the images along with the ratios, if possible. That might not work really well, but we'll see. All right, so ratio for this thing, then we can do it. We can say images dot append frame region edges. And you could have done that before, and it doesn't really change anything. And then my ratio is going to be the computation of my white pixel count divided by my frame region edges. The stash, yes. The frame region edges. That size. All right, so all the items in the matrix, the count of all the items in the matrix, that gives me some sort of ratio there. And I can just, instead of saying equal, I don't know why I did that. I say straight up ratios. Dot append, same thing. And then we're gonna do our white pixel count divided by this. And at the end of this loop, I can start showing the images and the ratios, right? It's been. we just all nod and pretend, right? Yeah. It's like, oh yeah. We know what you're talking about for sure. We know. All right, let's print out the ratios, and then skimage.io.im show collection. My images like that. That's probably gonna be like so tiny. I won't see shit, but let's give it a try. Okay. Come on. First try. All right, ratios. Ah, shit. Yeah, I thought it was gonna be too. Yeah, no, it's not gonna work unless we use matplotlib. Uh, but we have the ratios at least. So we're looking at the edge density ratios of all the candidates here. Well, whatever the contiguous objects of white pixels. Everyone's faking it. Yeah, totally. How can I get this to display like in one? I mean, we could look at one image at a time. Problem is, I can't just in case it's not it's not obvious. I can't show more than one. If I use individual images, I can't use more than one. So, but we could cycle it manually, right? Who says there's no manual work in programming? They're full of shit. What's the difference? There's not a lot of differences, Ruffsy. I prefer to use list because I've explained that before. It's just more visual when I'm kind of like reading code, like skimming, just diagonal reading. If I'm going too fast, then it's like, is it this? Is it this? Is it this? When you're reading like a big block of code diagonally, so list for me like attracts my attention way more than the other stuff. It's just a personal thing, really. All right, so there you go. That's the S of the so close and the ratio, and then we can keep going, of course. All right, manually because I can only display one image per cell. But we have all the ratios like this, and then I don't know. Can we kind of determine? Is there a way to? I know with matplotlib, there's a way to show all the images in one cell, but not with skimage. I don't know. I don't think they have that part. So it looks like it's kind of going in order here. So if I want to look at the ratio of the big guy, I would have to go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14 probably. 0 index, so 13. And that would probably give us the. And now, see, look at that. Like, just keep this in mind, just like roughly 1.129. Now, if we look at this, oh, is that the plus? Doesn't really look like. No, that looks like the plus. That's definitely not what I'm looking for. Did I? Or is it doing Y first? Oh shit! I didn't really like consider that. I think it's the. I think it's Y first, but it would still be 13 in this guy. I don't know. I don't get it. Maybe I could try +1 there, but yeah, it's probably +1. It's probably 14. The plus is the lowest Y of all this block, so it's gonna be +1. All right, so 129, 109, and then I get this big thing here, and it's way lower, right? It's way lower. It's ordered chaos. No, it's not ordered chaos. It's Y first. It's Y first. It's Y then X. The sorted order is Y then X. So it's the Y the row first, and then the X position. Yeah. So now I kind of have something I can use here. Right? I can kind of use this. I can say like, hey, look at that. The ratio is like an order of magnitude lower. And it seems like almost generous that it's that much. Kind of feels like it should be less than that, but it's probably because of this that's contained within. But I'm willing to bet, like, if we go for the other characters, we'll never get like some super low ratios. I think I'll do some manual work here. Sadly, again, I hate doing the manual work, but we kind of need to do it. I want to observe, like for all the other characters, that's a big nothing. Like, where's the nothing coming from? I don't. Whoa. Damn. I don't know where the nothing is coming from. Is it getting border cleared? Is it the question, like the exclamation mark here? Kind of hard to tell. This is not a real image. This is just the approximation. True a plot. I don't know where this guy is. It might be the dot of the exclamation mark. It could be all sorts of stuff. But see, like it almost feels like the characters every time they're at least over point one. So I think it might be efficient if I could try it manually to see what's left if I keep everything above 0.1. Right, it's always 0.1, 13, 0.109, 0.129, stuff like that. Might be an efficient way to do it. And we're working with the edges, not the full fill. And if we do the last one, no, the last one will be a character. That's not gonna work. No, okay. The best way to do this is not manually. Okay, fuck it. Let's just apply whatever we observe like super quickly like that. The 0.1, right? Let's just apply the 0.1 as a threshold, and everything that's under 0.1 density of edges, we're gonna filter out of the image. So what I'm planning to do, ultimately, now we don't need the images and all that, just the ratio, and we're not even gonna collect it. What we're gonna do is a little different. And I don't know if I can do that with NumPy. It's going to be a bit of an experiment. That sadly is a thing that comes up quite a bit with NumPy because you can't remember everything, and it's really vast and works differently from regular Python stuff, structures. But I'm going to try to fill in. A blank canvas essentially, so just like an image that has some zeros, which is going to be a black background with the regions that match this edge density over 0.1. So let's say our result, oh my god, what the naming is on point as usual, is going to be an np.zeros. I'm going to dictate the shape. The shape I can get from the frame, the original frame, so I can probably say frame dot shape here, and if we're not sure, we can always work with, I'll inspect the shape of our result. Yeah, seems good. That's the resolution of the game. That's good. Okay, so I'm initializing an empty like array or matrix with zeros, and everything that's gonna match our conditional, I'm gonna start overwriting that bounding box, that selection with the contents of the previous image. So we're gonna be left with an image that looks like this without the trash, allegedly the visual noise, if we didn't fuck up, right? And then we have to benchmark it to make sure that it's not too slow. Because if it's too slow, this was all for nothing. Because if it's too slow, like we're working in real time. The game is going to be running, the code's going to be running. It can't take me like 200 milliseconds to do whatever we're doing here. It needs to be way quicker than that, right? There might be ways around the slower operations, but we have to make it fit within. We'll decide on the budget and see what's reasonable or not. Essentially, my wall-to-wall budget right now is 250 milliseconds per frame that we process from the game. All right, so that's my budget I have to work with. And I say wall-to-wall, I mean wall-to-wall. Like it's like from the moment I get the frame to the moment I send the input. That's what I can work with. That's how much time I have to process and make a decision. Okay, so inside of that loop, this is where we're gonna do. We're gonna store the ratio instead, like this, and then we're gonna decide based on the ratio if we need to modify or append some data to result, right? Or maybe clean frame. So much better. Clean frame. Okay, so if the ratio is above 0.1, like we said, and this is an arbitrary value that we might get to tweak eventually, but for now we'll start with that. We need to start somewhere. Then what we need to do is replace the region in clean frame, right? So clean frame where the coordinates are those of this, right? So I'll do it like this. I'll do y0, Oops, y0, y1, x0, y1, because it's roll call and numpy. Right, and then I'm gonna try to say that it's my frame region, but I don't know if that's gonna work. We're about to find out the hard way. And instead of printing all this, I would like to show the final clean frame here with a CMap of gray. I think it's like this. And okay, great. Okay, no, it's the other way around. God damn it. American gray. Hey, first fucking try. Look at this shit. All right, we're missing the L. We're missing the L, but other than that, so maybe I can tweak the threshold still, but the garbage is gone, and now I have like the relevant stuff, right? So yeah, now we're missing the L, so maybe it's a ratio thing, but this is already looking so close. God damn you, fuck. Oh god, you guys have the same. All right, I see where you go. Yeah, okay. Yeah, real clever chat. Yeah, so close. It's a good start. It's a good start. I mean, the approach is kind of like sane here. It sort of works. It's a good, just from looking at it, like we're able to establish some way. So let's try to tweak the ratio. So the goal is to tweak the ratio to not, I don't know, to not include the trash, but also I'm not getting anything back. I think the problem is the complexity of the L is not going to be quite there, right? In terms of edges, it's not a whole lot, and it might even start clashing with, or it might not even see the edges. If the L matches the rectangle perfectly. Oh, but then I have another idea, chat. Oh, you have to be worried about that one. Then I could apply some pretty aggressive horizontal closing to make a big box, because I don't care about the characters. I care that they're you know, like relevant signal. I don't care about the individual characters, what they mean. Or I'm not trying to parse like the actual score from this. Aggressive. Yeah, aggressive for real. Aggressive horizontal closing. So if you don't know what closing is, it's we're gonna use an object, a shape, a sliding window with a shape, to look at the local neighborhood of every pixel. And what I'm gonna do is if the gap between two consecutive white pixels is smaller than the size of my shape, so basically if I see a white pixel and in my local neighborhood I see another white pixel, everything that's in the middle will get flipped. So that's closing. Opening would be the opposite. Opening would be like the flipping of the white pixels to the black pixels, right? But if I do this, if I do some sort of like close, Doggo is licking the couch. What? I just saw that. That's beautiful. Good job. Real smart. Yeah, then I can make some boxes around this. I know. Maybe I'm doing too much. But even with 0.5, it's not showing the, it's never going to show the L, I think, in this case, because it look like the L is probably a rectangle. Yeah, look at the L here, or perhaps even better, look at the L. Oh, no, that's not the right one. Shit. Where is it? Nope. The L here. Windows with stupid bullshit like overlay on top. Yeah, it is a perfect rectangle. It's kind of like a lazy font, right? So my whole like let's detect the edges. My bounding box is precisely the L. So that's not gonna work out. However, I have another trick up my sleeve. Always have tricks up my sleeve. I could expand the bounding box a little bit, if possible, and then I would force an edge detection on this. Right, once I have the bounding box from the object detection, the one I could consider for edge for edge operation, the edge operator would be a slightly bigger bounding box as long as it's within range, and then it would force. There's always tricks, right? There's always tricks. You need to learn the tricks, and then you chain the tricks together. That's kind of like how image processing works in the end. Yeah, that's another idea, right? So I could just like, let's detect it as is. But that's if I cared about the characters, and I don't. I really don't. Why not ignore the box if it's too big? Because it's a bounding box. And if I delete, I just black out everything in here, I'm gonna delete the score, and that's really important. Like, I want that. I don't want to get rid of all that. So yes, like the bigger object in this case could be deleted, but if you have a case where there's nested information that's good, then you're getting rid of your nested information. Not good. You don't want that. That's not the good part. You don't want that. So that's why I'm going with this, and it doesn't seem to be really complicated. I think I still have the bounding boxes also. Huh. There's another trick we could do to kind of like normalize the amount of pixels to a certain range. So instead of keeping the characters, maybe I could keep. So instead of setting it to the mask of the frame region, I could set it straight up to 255, and then it's going to be boxes everywhere. Like this, right? And then I could do the closing on the boxes, but it's aggressive. I probably don't need to do that. But the boxes already detected the digits. I don't know what you're saying. I could probably mask it. If that's where you're getting to, I could probably mask it in place if it's too big. But I don't like if it's too big, because what if we come across some other bonus or something scales on the screen? It's too simple it's probably too simple like a thing to pivot on. I'm not a big fan of that. Right? It's too big. It's okay until you see something that's big enough to fit in your like over your threshold. It becomes an n+1 problem essentially, right? So you think you nail n, but then there's n+1 that shows up, and you're like, oh fuck, better make it better or bigger, and then n+1 again strikes later on in a specific edge case. I don't like to pivot on something so simple as hey, it's too big or it's too small. There are other properties that you can kind of get to that are just that are probably more indicative of if it's what you're looking for, right? So the whole edge thing with the L, I could fix it if I expanded by 1 pixel the bounding box. I don't really care in the end. I care about my I really care about like the pixel count and removing the trash. But I guess I could use the mask if just to answer that part of your question. I could use the mask of the white pixels inside of that region and turn them into no, that doesn't work. I can't do that. I just can't do that. No, it doesn't work. It would get rid of these digits too, and it doesn't work. What I'm doing is probably like the closest we can get to something without the trash. Now let's try the same thing on our frame A, which we consider it a little simpler, and see if we still get what we want here, right? So that's the frame. It has some score here. It has a multiplier. It has some other garbage. Now if I try this again, maybe not save it as an image, but oh, see, we have an artifact here that stays with this sort of well, that's interesting. Why do I have this artifact that stays there still? Because my score is here. If I open the full frame again, it's this one. So I think this is a combination of being small enough and still having edges. Complicated. I mean, it's getting the 89 and the ×2 correctly, but and it takes away all of this, but it keeps this guy here. Is there a way to, like, a second pass that we can do to clean, perhaps? It's probably what it's gonna be what we need to do here. And maybe the smaller images, I'd like to save that representation too, because maybe the smaller artifacts are still there. It's just that we can't see them on the plot because it's too small. So I'm gonna try to save this to disk 2. I'm just gonna smash my fingers on it. That's gonna be the file name, and clean frame. Oh, no. Where did it it is file name and array. Maybe use region props and just divide the area perimeter to area. Yeah, that's one way to. Are we talking about like cleaning it further? Shots? Is that what we're talking about right now? It doesn't like my clean frame for some reason. Images of type float. What causes it to be type float? So before it crashes, let me just look at clean frame, not dtype. What? Why? Why? What happened to you? Why are you a... I did say as you byte. After the canny. And the zeros should not be... Oh! Okay, shit. I think it's this guy that initializes its array as a float. Because I didn't specify any type. Just give me a sec. Yeah, D type. I'm gonna say uint8. Not a bug or anything. It just prevents the saving. There you go. Shit, just lost my shift key. Interesting stuff is mostly a group of boxes, never single boxes. That's a point too. A group of boxes. So do you have a simple like metrics that you could like pivot on? You have like a way of doing this? No, so it did filter out the smaller, so that's good. The smaller boxes are gone. I have a multiplier in my score, and this little extra piece of information. It might still not be. This is still perhaps like within the realm of the acceptable, because like it's not going to tilt the entire the entire like group or range of white pixel values that we were using to determine the scores. It's probably not enough to tilt it towards the next tier of scoring. So I don't. Maybe this one isn't that bad. And if I switch back to the other guy, this guy here, try it again, and we open. Oh shit! I don't know why I ended up with the full screen image here, but well, we did. Windows. Yeah, it looks like this. So that's also pretty good. I'm kind of okay with this. Kind of okay with this processing. So I would have to do the region props. I would have to do the NP zeros and then just like populate the new frame with whatever we detect here. I'm also okay with using 255. It's probably going to be quicker to just assign. And then everything else can kind of go there. And then I'm working with clean frame in the end. So what's the processing on this? What's the cost? And this is the scary part, because we have a working solution, but if it takes too long to do all this, then we're in trouble. Come on, baby Jesus. Oh shit, that's bad. That's really bad. That is really, really bad. That is really, 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 really bad. 140 per loop. We need something simpler, chat. We don't even have the thresholding in this. What takes the longest? I think the canny edge detector is probably the thing that takes the longest here. I don't see other like operation. Oh shit, I'm still appending to images. That is not okay. It probably doesn't change shit, but and then what else were we doing? We were calculating the ratio in order to populate the new image. What takes so long? What's the big deal? Is it like calculating region props on such a big image, or is it the canny edge detector that's taking so much time? Because this is not good results. Over 100 milliseconds for this, not gonna work for us. No. Okay, shit. Let's try to take out the canny edge detector first. See if it makes it faster. Fuck, it is the canny edge detection that's taking forever. Like, see, this would be acceptable. Like, around like 40 milliseconds out of our 250 milliseconds for the wall-to-wall. That would be fine. But the edge detection is too expensive to run. So we have to rethink this a little bit. We're not done with the problem just yet. It would be awesome to be done with the problem, but now we can play with the parameters of the canny edge detector. Except that there's not much. I mean, okay, now it's giving me the stuff out of the U-byte. Let's see, in the canny edge detector, is there anything that can be done to speed it up a bit? Because that is way too slow. Or is this or is there another edge detect edge detector that we could apply that's easier? Trying to see if there's another one, because of course the canny might be accurate but slow. No, there's always a better and a worse one. Shit. What else can we use? Why are the other ones in filter and this one is in feature? The other ones are here, right? I mean, can't I technically just apply a convolution on that small thing? I don't understand why it's that slow, man. Is it because we're doing it every... Yeah, there is Sobel. That's what I'm looking at right now. I mean, technically, we could just apply a convolutional filter like manually to have some sort of edges. It doesn't have to be like really good. But I don't know, like if Sobel is gonna be faster, but we could try. We could try. Just like swap it with Sobel and hope that it performs a little better. It's not going to give us the same representation, so the ratios might change a bit. I mean, we are doing the edge detector on many candidates here, but... Oops, shit. Insert Sobel on frame region. Nope. Filters. Filters. Please be good. Please be good. Please be good. Please be good. Okay, it's better. It's better. Is it perfectly acceptable? We'll see. Maybe I can still... Oh, shit. I just thought of that. Oh, wait. We can make it faster. I can still discard big regions here. Because I know Gaga, you were saying if it's too big, we can ignore it. And I don't know what sort of ignoring we had in mind. But if a box is too big, I don't have to do the processing. I can probably eliminate it like right away. So I could do if region If region.area is over a certain arbitrary value, we could just skip to the next region. All right, so let's say, I don't know, that's the problem. I don't know what's a good value here for this. And then all of a sudden, maybe my 70 milliseconds is going to drop quite a bit, because I'm not going to try to perform Sobel on, see, it just dropped by 20 milliseconds, because I'm not trying to do Sobel on like the larger regions, right? Are the resulting images still good? What do you mean by that? Oh yeah, just keep going, essentially. Yeah, let's do that. I'm not looking at clean frame, but we still have it in scope, so I could definitely like output it. Let's do skimage.io imshow. I'm sure you guys know imshow and imread right now. The amount of times I've ended up doing it. You probably know it by heart right now, even if you've never done anything with that. Like I'm using this so much in the end, right? And it just needs a color map because it's grayscale stuff, right? So like this. Yeah, they're still good. They're still good. So I guess the ratios aren't too like that far off, and we're still getting something that looks a lot like what we had before. Now I guess I could tweak this, try to find a sweet spot. That would be awesome. I mean, this is probably the sweet spot. I would need to know what the size of these things are. Shit. I think I can lower the threshold, because the biggest thing I'll ever see is probably that text, right? The awesome and then the so close. Taco. Doggo's being a little special today. I don't know what's going on, but she's being a little she's sitting in the chair in a weird way right now. I don't know what's going on. It's like a floor sit but on the chair. It's just a little weird. I'm not judging, but it's a little weird. Like just a human sit. The only thing that's missing is that she's looking at the camera. That would do it. Okay, so if I do this, I'm sure we're gonna lose out on a lot of stuff here. It doesn't even improve the performance that much, and then we're gonna start losing out on some. Oh, we're not. Huh? What did we lose here between? Isn't that a couch? It is, but I don't know, man. Dogs will lay on couches, not sit on couches like that. That's a little weird. There. Sorry. 47.5. It's a US one-seater, he said some streams ago. Yes, I did say that. And NA. I didn't specify US, I said NA. All right, 47.5, and we're getting good results. Okay, I think that's expensive, but we can deal with that. We can definitely deal with this sort of stuff. It's probably enough. So if I bring in some other trash frame, okay, maybe this guy's gonna not get filtered in with the 2000. We're about to find out. Oh shit! Right. So the time it discount. Oh shit! No, that didn't prove anything, chat. God damn it! Because the time it is not kept in scope after we run it. So that didn't prove anything. That didn't prove anything. Yeah, no, that's a way too small. Okay, let's go back to like 5,000. Even 5,000 is way too small. Oh, now you're just lying though. That is bullshit. Maybe it's the ratios this time around, right? So let's see how many times we. So I don't know, 5,000 I still think is a nice one. Yeah, see, we get a lot of candidates with that sort of threshold, so it's definitely not the problem. It's our ratios that are all fucked up now. Interesting. Gotta go to sleep, feels bad, man. Have fun with this problem, Cap. I'm not having fun with this problem. It's a necessary problem to go through. All right, so you'll definitely do, if you do that, you want to do that sort of work, the sort of experiment that we're working on right now. Eventually, you'll have to deal with stuff like that, right? There's no real like running away from it. So remember that when the experiment runs, right? Where we do the 24/7 experiment, because remember this moment right here, right? So it was not just like a matter of like slapping three things together and there we go. There's always some specificity to games that will cause you to work with your brain quite a bit. Right? Get rid of the ratio doesn't work. Well, no, it's just because the ratio. The reason the ratio doesn't work is because we just changed from Canny to Sobel, right? So the ratios are different. Uh, I would have to print my ratios for these candidates to understand. Like my. It's not that the ratios don't work. It's just that we need to know what they are. What? What? Okay, so Sobel is faster, but it doesn't give me anything. That's fucked up. Wait, let's try Sobel on here. Something's not adding up here. If I want to save it to, I saved it to name.png. Ah, but it's not. I would have to threshold it again because it doesn't give me it doesn't give me some sort of like binary representation. It brings it back. There's smoothing. I don't know if I can take that out of Sobel because it's faster. I don't need the order of interpolation here. I can use order 0 and be happy with that. It just did extra work for me essentially. I don't want that. Because now the threshold thing doesn't, like, this part doesn't work because it's not 255 anymore. It's not like pure white. It's some sort of like shade of, you know, like on the grayscale. And if you don't really believe that, then we can, you know, probably like print out the max of the frame region edges. I mean, it was kind of visible from the image like itself that there was some sort of like shading going on and not just like a binary image. But I could print the frame region edges as, well, the max value. And then we'd probably not see some 255s in there. See? 202, 202, 202. I don't want to, it seems like a pattern, but it's not. See, there's 180. I don't want to say like, yeah, this is a specific one. Okay, so Sobel is definitely faster than Canny, but it's also not giving me back a binary image. This is probably where the filter is coming from versus the feature. I almost kind of want to bring back Canny and with the exclusion of the larger image, to see if we can kind of get away with that sort of performance, right? See, when we exclude like this, it's going to prevent me from doing Canny edge detection on something that's super like large, which is probably slowing it down by quite a bit. So if I bring back feature Canny here, and then my ratios are all here, and then it would work again. Okay, so let's say I remove all the, well, the yo is definitely not needed anymore. That's for sure. I could keep, well, the max is clearly 255 because Canny will do the binary image. So that's also something I don't really need. I expect it. And then the ratios, we could keep them around, but printing during a time it, probably not necessary. I want to calculate the time it takes to print something to the console. And then we can do the time it again. Oops. So of course it is, I'm expecting it to be a little slower, but this time around at least I'm filtering out the stuff that will probably slow it down the most. The larger, and that being, yeah, see, so it's a little more expensive. I'm still not a fan of this sort of like almost 100 milliseconds though. So either we get like Sobel working and would have to re-threshold the image on Sobel manually to get it back to a binary image, and I would get some probably like around like 55, 60 milliseconds for the entire operation for the entire image, which is expensive but still acceptable, I would say. Still acceptable. I don't think almost reaching 100 milliseconds per loop on this thing is not fine. It's not, sadly. So let's revert it back. Let's just like bring these things back and go back to filter Sobel. And before I do the image as byte, no, I can do it there. Perfect. And then I can just say the same thing again a second time. And I'm going to say it's going to be this guy over a certain threshold. And we've seen the threshold a bit. So it was, let's say, around 150. That would still work. You can print the ratios still. Are they still 0? Really? Why is my thresholding not doing anything? We haven't changed the original frame, right? So it's still there. Frame region edges dot size. I need to do this on, oh my god, on the other one too. Yeah, no, I get it. I get it. It's because this returns a true or false type of deal. If I don't intend to use the image, however, I could just adjust my Haha, there we go. Haha. Aha. All right, now we have some okay, now I have some more information here. And if I were to look at the clean frame, yeah, now we're getting the same result as we did before. Whew! All right, it's a lot of work, but we're getting there. So some of them are bad candidates, but most of them are above 0.05, and I would even say like all of them are above 0.1, so we could bring the ratio back there. Let's try just like with the other one here, and then I didn't benchmark it. That's another thing, but I think we had an idea of how long Sobel or how expensive Sobel was in this case. Oh, see, we have one that's under 0.1 here. So there, sweet spot. Sweet spot, right there, right there. All right, it's starting to look good. Starting to look good. So now I'll just benchmark this operation to have some sort of idea of the impact on that it's gonna, you know, like how long does it take to really like run this reward function on every frame? Because really key information to have on the hand. I have one job essentially is to make it fit within the time budget that we have. If it doesn't fit within the time budget, we're gonna have a bad time. Excellent. Around 50. Around 50. Might be the unwanted dot in the middle. Maybe. You're right. All right, let's remove the timing. I mean, the timing is definitely satisfactory. Around 50 milliseconds. I can deal with this. Because calculating the reward score, and then we would have around like, you know, like a little less than 200 milliseconds to run something through the neural net. Definitely not that bad. I mean, it's reasonable. I don't think we're going to break anything with that sort of cost in milliseconds. But you're right. Let's try to see if it is just the unwanted garbage in the middle. For that B was it frame A? Yeah, frame A. This thing that was registering earlier. So if I decide to go ahead with this and just go back to the 0.1 and look at the generated image, did I answer the cat? Totally. Oh my, what? Wait. Okay. It's more than that. I'm also losing out on my. I don't think it is, man. I think I'm also losing out on my my other digit right here. It's a good point, Dekarki. Like it's definitely. Ah. You want to laugh? You want to laugh? I think it's because there's one that's like exactly one. There you go. There's one that's exactly one. Ah, shit, man. There's one that's exactly 0.1. So it was that my other digit. It's still very. We're on thin ice still. All right, I would say we're still on thin ice here. Like this is probably not. I wouldn't bet like the. I don't know. It's probably not like a safe bet that like it's getting a very arbitrary for my tastes here. I think we're like overfitting to these 2 frames in this case. Like we're just like saying, hey, nah, for sure it's gonna be fine. Like no problem here. Let's try that again. Yeah, so we're losing a few characters, I think, here. But in the end, it doesn't really matter. It's going to give us like some detection of these things. Let's take it for a spin. Let's take it for a spin, okay? So this is the new processing for the reward function. And I don't even... Huh. I'm thinking we can make this faster. That's always a good thing. We can make this faster. I just thought of something. I don't need to add the new image. I just need to filter out based on the well, first of all, just on the ratio. And then I can just add the pixel count to a counter instead of appending to a new image. Okay, whoa, this might change a few things. All right, so let's bring back our time it here. Because in the end, don't forget, I'm using the amount of white pixels. The amount of white pixels to determine like the range of the scoring. And yes, we had the use case where I had to take out some noise, some trash. But I don't need to put it on a new blank canvas to count the white pixels. I already have the white pixels. All right, so let's do this. It's gonna come around like a point. Oh shit! Why is it longer now? It's longer to process on this one. Look at this. Let's say I remove this and this and I'm gonna keep going and say the white pixel count of the entire thing. How do I call this? Well, the result, I guess, starts at 0. And if we pass our I should have kept the if ratio. That's still valid. Is greater than or equal to like 0.1. Then we can result plus equal the white pixel count for that region. Yeah. Okay, what's the damage on this one? It might still be around the same thing because of the Sobel, but yeah. Shit, it's still expensive, man. Like 83. And then I could show, like print result and clean frame, whatever. No, but the time it doesn't really. So it was just faster on the other guy, obviously. For obvious reasons, it was faster on the other guy. Because it had less garbage. This one has like more garbage. I should be excluding the large sections, but and that was supposed to be result. And result is how we choose our reward, essentially. Yeah, so see 17. And let's see how it compares to my initial ranges in my code, right? Because that's kind of interesting to see how it correlates to that. And then we had something along the lines of, it's different. It's different now. That was the bonus, and a bonus is if you have a score and that would fit in this range, and it should be the 1. So we're gonna need to readjust. What's up, Taco? How did we have so many white pixels? Probably because we were picking up some garbage. I hate to say it. I don't know. This range seems a little weird to me. Like that we would give max score for between 8,000 and 30,000 white pixels. That seems like a lot of white pixels in comparison to what we have in our little sample here. And I was still doing some sort of like thresholding like that and nothing else, right? But the white pixel count has nothing to do with the clean frame now. Clean frame is not even a thing. So it's not the pixel of the... I want something more consistent. Instead of using the white pixel count, I can count the entire region as white, I guess. Ugh! And now we'll get to visualize if that's gonna work out for me too. Is it still 1702? It is. I don't know what to say now. I want to take this guy out. I want to test this guy out. I want to take it for a spin, but it's a little slow still. Probably because we have a lot of candidates in the case of a bonus. And in a normal scoring or no scoring situation, it would not be an issue. Okay, let's take it out. Let's take it out. I mean, I'm hesitating a bit here, but what's the harm in trying it out, right? Let's bring it into play here. This thing, this logic. And I think before we start like using it and mapping it to a reward function, what I should do is just like save the frames as I was doing in the handle play here. So let's start from that black and white frame. That's going to be our thresholded representation. Ah, shit! But I was doing the extra. I was doing the extra work here. All right, and that is all measure stuff. I think SK image, because I was using. Just gonna fix a few things for a sec. Region props is also in measure, I believe. And if not, it'll tell us really quickly. And then frame is always black and white frame. But to save it properly, I would need to apply the logic that we were. I would need to bring back the clean frame thing for a second. And that was np.zeros with the shape of the black and white frame. And a type of t type of uint8. Okay, and then on top of just like adding the pixel count, I would need to populate clean frame for the I should have kept that. Like this is equal to frame region. Or 255, like I said. Every one of these. Yeah, it's probably better like this. Alright. Let's try that again. But this time I'm going to be playing the game. It's going to save some representations of what's going on. So in collect frames, I'm going to clean up a bit. Or maybe we could keep the old representations just as a reminder of before and after. Maybe we could do that. Before and after. Let's do that. Yeah. Or we already have our before and after here. Let's just like look at our new data then. Okay. So this here. So we can play Super Flight with the game agent. And I'm going to start messing around here. Hey, we're not recording yet. That's fine. We're not saving anything. Hopefully, I recorded that part. What are the black and white picks all about? It's trying to fix an edge case with the score, the isolation of the score in the game on every frame. The edge case happens on a level like this one where it's like super foggy and there's no tint to the fog. It's mostly like a white fog. So all this time that I spent liaison like in the notebook with these black and white frames is trying to address this little edge case, this little problem here. So not only do I have to find a solution that gets rid of the problem introduced by the edge case, but I also have to make sure that it's fast enough to not eat up too much time in our frame processing. All right, so it was kind of rough. I know it's not as, like as hype as the other stuff we normally do, but I can't really change my process just because it's not necessarily like the most PogChamp thing. It's an actual problem for which we need an actual solution, and we have to figure it out. So right now I believe we have something that sort of works, but I have to collect some new frames by playing the game to just see if it takes care of the issue. All right, so that's what I'm doing. It's a little hard. You have to actually use your brain for that stuff. It's not just relaxing and like I said, slapping 2 or 3 things together. It's a little more involved than that. So this is the sort of moment I said I remember those moments when we run the experiment and people think it's fun to watch. I just remember that we had to work for it a bit. It's not a matter of just assembling IKEA style the experiments. Get some scores. All right. I think I have enough. Like I have some awesomes, I didn't really get us so close. I did get some awesomes, I did get some multipliers, I did get some scores. I think we should start looking at our. I would have loved to have gotten this so close. All right. What's the current method? I am in the middle of collecting data to see if it fixes the issue shots. We'll see. Sobel magic. I mean, Sobel is still very expensive in the end. That edge detector is, even on smaller samples, is definitely not like fast. But it's still within acceptable range. So, okay, so let's do it now. Let's just stop it. Look at all we collected. And wait, did I not delete the... Oh shit, we're still getting this? Right, why am I still getting all this data here? No. Saving the wrong ones? No, but unless I didn't apply the entire code to it, I don't... what? Okay, I know what I can do. Because this is exactly the edge case. This is exactly the problem we're trying to get rid of. So either our solution is shit, or I didn't hook it up together properly in the experiment. So I'm gonna copy this and then call it frame C. That is coming from something I just collected from the gameplay, right? And I'm gonna try to bring it back to the notebook to see if I apply the notebook stuff to that image. Are we still good? Because there might just be a little disconnect. All right, so it's this thing, and if I apply whatever we applied here, it should totally discard the big thing simply because of this right here. Right, the whole if it's too big, skip it. I don't really see how. And I'll bring back the clean frame. I'm not saving the clean frame. I'm saving the fucking original. No, you're right, the car key. Totally. I just realized that. I was like, wait, what? I'm not saving my clean frame. I'm saving my black and white frame. All right, let's play the game again. No, you're totally right. I didn't swap that part out. Brilliant, amazing. Let's go back to collect frames and like empty this. If you're wondering why Doggo is so active versus Doggo sleeping normally, is because there's a bit of a snowstorm outside, and like dogs and snow and whatever. And like she's hyped. She wants to go and play in the snow. Yes, definitely failfish there. It's just that working on the solution, they actually melt your brain. They melt your brain, okay? They melt your brain. Taco butt. No, they melt your brain for real. Right? It takes a toll. It takes a toll after a while. So even though we're solving, I'm gonna start making more and more silly mistakes. All right, let's try it again. All right, so now I have to get some actual good gameplay in to get my little qualifiers. Not necessarily like get a high score or anything, but just get different labels to show up, essentially. That was awesome. Good job. Oh yeah, awesome. Perfect. Got an awesome there. That's gonna help. Now I need some sort of like multiplier also to make sure that we got everything. Other than that, I think we should have enough. I did go like fly out in the void and also in the structures. So just maybe trying to maintain some sort of multiplier combo or whatever. It's kind of hard with this specific level because there's not a lot of walls you can hug forever, or floor you can just hover on top of and then rack in the points. I'm trying my best to get the multiplier. Yeah, there we go. We have a multiplier. Okay, perfect. All right, that should be enough. So we got an awesome, we got a multiplier and regular scoring and no scoring. Ha! All right, let's go. Let's see what's up. We still have some artifacts. Motherfucker. It's definitely better. It's definitely better now, but it's still not perfect. I see, because we're counting this, we're getting a score here, but there's still some visual artifacts that are kind of in the way. And how do I deal with this? This could be score for all I know, so I don't want to, you know, like question it. This is definitely score, but there's still. Oh, could it be the score fading away? You know, like when it no, it would still follow the same structure if it was the score. So there's still some artifacting, but it's not as major. However, in a situation like this, it's pretty bad. Because there's no scoring going on here. It's just artifacts. That looks like a multiplier to me, and that looks like a score to me. It's really hard to tell, but maybe I could score. I could save also the full version to just like confirm that there's actually scoring going on, because it's really hard to tell. Some of the vertical artifacts I could definitely get rid of, because there's no text that's going to be this tall, right? So if we could look at the bounding box and remove something that's too tall, technically, right? Yeah, I need to save both images. I know. Yeah, I think we're going to do that. And I can, right? It's just another line. It's going to slow it down, however, a little bit, but I could do frame full, or just like keep the timestamp there so that we have them in order, and just say full, and that would just be the game frame.frame. But that's going to slow it down a bit, so it's not going to collect as many samples. But there is an additional improvement that we can take there and apply there already. It's just the vertical. There's a limit to how like valid possible artifact. There's no way like that a piece of text is going to be this tall, right? So we can analyze or observe, and maybe that's what Shach was saying earlier, right? Was saying like look at a bit like the aspect ratio of your. There's definitely some stuff that if it's under a certain aspect ratio or over another threshold, like it's probably not a good candidate and just garbage. So size is a thing, but aspect ratio is probably even a better tell. Let's run it again and just like save the actual frame next to it, like the color frame. And it's definitely getting better. Keep in mind that this is the edge case. Now if I go and play in a regular level, we should get like almost perfect results. unless what we did here ruins our perfect results from the original frame. That would suck. That would be kind of bad. And in terms of optimizations, there's also something we could do, right? If I could count the white pixels when I threshold originally, if it's over a certain quantity, then we could say, hey, there's probably some artifacts and run the more complex one there, right? Blank image. No, don't say that. Don't say that. I don't need this. I don't want that right now. That's definitely not like that would be so bad. Fixing a problem by introducing another bigger one sounds like programming to me. All right, let's go. Just run this. I don't know why I'm going through the pain of playing through the with the keyboard. I'm an idiot, really. Like I'm not recording, so I could play with a controller and just like generate much better samples by not sucking with analog. You know, like analog input is definitely better for this sort of game. So I don't know why I'm playing with the keyboard. Maybe it's just like pain. Could just do some better, you know, like moves in general. Most of the time. Most of the time, just do better moves with the controller. Yeah. All right, so I still need to generate some sort of like awesome. No, that's not gonna be enough. Okay. I don't know what I was thinking there. Okay, come on. I need the awesome. I think we got the multiplier already, but can't tell for sure. Okay, awesome is acquired, and then I just need some sort of multiplier in here. So shit. And it's gonna look exactly the same way, but at least we're gonna have the reference full color frame, right? Restart from the same place as normal. Well, at the same level, it's gonna restart for the same at the same place. As long as you're in the same level, but our agent will definitely encounter some other levels at some point. So I'm not too worried about that. And even there, like I don't think it invalidates anything. Even if it's the same level, it learns to perform in an environment. I'm kind of happy that it will get other levels though, because it will definitely try to be. It will be submitted to because I don't know if you've seen that the Dork Knights. Pretty funny name, by the way. That's if I dive, right? If I just run out of level, it will generate another level on the fly, on the spot. So it's not we're not stuck in this level forever. Right? It's just gonna do this the next time around. Oh well, good time to no. It's not a bad idea. Let's try let's try to kill two birds with one stone. Let's see that I'm still not fucking up my regular because this is never gonna clash. This is not an edge case level. So I want to make sure that my stuff still works here too, without any sort of artifacting and. Where can I get a Oh, I did get the awesome. I don't think it captured it though. I don't think it captured the awesome there. All right, so awesome is when you kind of like fly in like a tight spot and get out of it. And so close is really just like a really close call to hit the wall. There is also a godlike, but I don't know. I don't remember where that comes from. I think it's combo maybe. I don't think I can generate a godlike sample, unfortunately. All right, that's enough. That's enough. So let's look at everything in there that we collected. So see, now we get side by side. Like we have the full frame and also the artifact or whatever, like whatever thresholding the thresholding yielded in that case, right? So let's just like consume them like sequentially. So see, there is an artifact here, and what's cool about this? That's a really good idea to save both of them, because I can just like roll the mouse, and I'll see that it's actually the gap here that caused the artifact. Now, why is it the gap here and not anything else in there? I don't know. Is it because it's probably because it's closer to the center, and then there's a very tiny vignette effect, like I said, And the closer you get to the center of the screen, the more pronounced. Like it eventually gets like caught in the threshold. Right, but that's an example right there. And see, this one has nothing. Oh, well, that's bad. Is it the size? Hmm. Oh, no, no, no. Maybe this is fine. Maybe this is fine. Because maybe this is not score that's being accrued right now. Maybe it's just a 2 that got committed and is just out of the way or something. But don't they fly away with the plus sign, though? See, this worked. Oh, this was a great idea, by the way. Thank you for mentioning that I should save both representations. Look at that, how easy it is to say if we're detecting the score or not. It's actually pretty easy now, right? And there you go. Another artifact like under the wing, around the center area. The score is getting detected. The 2 is a little worrisome, I won't lie. And I didn't detect the score. Oh no, I did. Nice. I got detected the score here, and there's another gap. That's a little tricky, man. But we're doing good for the most part. Bit of artifacting again. That's the death screen, so doesn't really count. Oh, that's a lot of artifacts right there. I don't know why it counts. So this is good. I don't care that it considers it like separate. It's not the end of the world. Okay, so if I were to remove, let's just evaluate this like manually, like really quickly. If I were to remove the vertical, like the too high candidates, I would still get some pretty clean results here. For the most part, 866. High for the third time. What's up? See, we're even detecting like the score against this background. So there's this again. That's a bit of. But then again, I'll never have a character that's this big, right? So we could filter out on under a minimum size and also aspect ratio stuff. That could help us. Yeah, again, the legs. Similarly, I'm not expecting like that's it. The aspect ratio is kind of a big deal, right? Yep. I'm definitely. It's gonna remove a lot of them at least. Shotch, I agree. Right. See, even the horizontal ones, if I filter them based on the aspect ratio, because a character will be around like 0.5 to like 1, something like that. And if we get something like that or a certain height that's too big, it's definitely not a good candidate there. Okay, that's fine. You might think that this is bad. This is fine. We're not interested in the scores that fade away because they've been committed. This is kind of like the similar situation. I'm guessing this one started to fade away. Not too worried. It could also be that the detection is the threshold's a little too tight. What's up, Nameless King? 51's getting detected. Okay, we can clean this up quite a bit. Maybe this is gonna be impossible to clean up. However, this one I will never be able to clean up. Like something that's exactly like the same sort of aspect ratio as a character. That's gonna be hard. That might be a case where. But then again, think about it. It almost looks like a plus that would be appended here, so it doesn't really change our reward function. I think for the most part, we can clean this up real good. Oh, it's missing out on a character here, probably because it overlaps too much with a zone that would also be included. It doesn't matter because it would still detect that it's scoring essentially. The 3s seem to be a little. Yeah, I'd have to be careful with my minimal size here. I don't know why the 3s they get thresholded like that. That's a little weird too. Ken, will you discard the ones? Which ones that are what is a one in this case? The ones that are too similar. What do you mean by that? Because other people said like of course the local cluster type of thing, right? That was another thing. Yeah, it's only a single pixel. I know, but the fact that I'm thresholding pretty aggressively, Shosh, doesn't help. It might get rid of the like one connecting pixels that would make the difference, right? Well, I can't know, right? I can't know if they're too close to a digit, and this is bad. This is one of the first examples of something that's getting missed uh, totally here. So I'm interested in that image. I almost want to keep this frame and then explore why the 8 is getting thresholded out, because that's one of the first times I see an actual missing digit against a legit background that it should be able to, like detect it from. Like I've seen some cases where it blends in the edge case area, but this is the first time I see one against like the purplish background and it's not there. Huh. Oh shit. What? Please tell me that's not real. How? That's because we don't see the thresholded version. I might have to slack the threshold a little bit. I think it's too aggressive on the 7 and a 3 and stuff like that. And not even the oh wow. Can I copy this? Yeah, thank you. First thing I'm satisfied with in this Windows tool. Let's keep this frame. Let's keep this frame. It's interesting. So if you really hate that shit, I have bad news. We're not out of it yet. We're definitely not out of it yet. There's still some cases. If I'm over filtering on in some cases, it's not good. See, we're still. Why? I think it's too aggressive of a threshold that causes that. Might lose a connecting pixel, like Shasha was saying. And I'm not supposed to detect. Oh man. This is not fun. This is starting to not be fun. Because now I really question, like, did we really like make it better, or did we just like end up making it worse? Because I mean, in a lot of cases it works, but and that's still our edge case scenario, right? So I'm not gonna be too harsh, but okay, where's the non-edge case? That's the one I want to see at this point. I think we've gotten plenty of samples. That's probably gonna be a while out still. But no, this is starting to annoy me just a little bit. Starting to annoy me just a little bit. Can we please move on? Or I'm just gonna go and click the right frame manually, where we start working with the new level. I want to see the state of things in this one really. See, we're missing out on the 3. Then we see the 9. That's actually pretty good, but it sees it as separate parts. Because otherwise it would just be a full block. Now it's 2 blocks that are almost one against the other. Aye. What? Shit, man. It might just be a matter of tweaking a few values in our thresholds. Or something like that, but this is still not good. I'm getting this for this. Ouch. I think the thresholding's a little too, aggressive. 'Cause, I mean, a lot of cases it works, but I mean, in a lot of cases it's not good. So I'm not gonna be too harsh, but this is still not good. I'm getting this for this. Ouch. I think the thresholding's a little too, aggressive. Some characters do better than others. Seems like this diagonal here. I don't, it could be the ratio also that's filtering this segment out. I don't know. This is an example of something that's really good. Seems like look at that. The diagonal is also not like it's the connecting pixels for sure. The diagonal is gone here in this case. Look at that. We have the bar, but we don't have the diagonal part. So I think that the thresholding is too. Okay. Okay. Well, I think that's enough data for now to keep going. There's definitely good news in the sense that we can probably remove a lot of the artifacts, the visual artifacts, by applying some logic on, you know, like vertical, like the height of a bonding box and also its aspect ratio, so we can filter out a lot of like illegitimate candidates from that. But then we have these weird cases where I kept a copy of the full frame, where we're not getting really like what we're expecting. That's the sad and scary part. I'm gonna take a little break. I need to, you know, like get some fresh air or something for a sec. Just to come back to this, I'm definitely not stopping anytime soon, but I have to kind of just like give my brain a little break. I'll be back in like 5 minutes. I can give you full screen doggo in the meantime. All right. So we're just gonna bring these two frames in the notebook and try to tweak our current implementation to just like make sure that we're not missing out on obvious. I think that the case in here is that I'm getting some obvious misses, right, on some of the detections that should not be a problem. All right, so not detecting some parts here is scary. Random agent. You want to see the random agent, or because I could give you, if you prefer the random agent versus the doggo, I could definitely give you the random agent. It's not exactly difficult to go back to that. You want to see the random agent against the beautiful pink land? I can do that. I just have to do this and wait like about 30 seconds. But I'm gonna take a little 5-minute break. Okay, so let's see if it kicks in. It's probably better entertaining than doggo. The ideal world would have a random agent and a doggo, you know, like at the same size or something, like just like side by side, and then everyone can be happy. All right, do your thing. Anytime now. No? Windows. Yeah, there we go. Getting all the issues. All right, so I'm gonna take my break. Okay, I'll be back. Just enjoy this random agent doing random things in the meantime. All right. Obviously, I'm back. Obviously. I forgot my headphones. That's why I had to go back. Just going to pour some water. Just give me a sec. All right, so you guys have observed that the score. Are you 100% sure on that? Because if the score is always in the lower half, we could already do some pretty... But yeah, no, that's it, right? The bonuses appear in the top half, so we can't just, yeah. That would have been awesome, but no, the bonuses appear up there, and we kind of have to be on the lookout for them, so I don't think it's a solution. The car key is right. The car key is right. All right, let's stop this guy. For now. All right, so yeah, no, we're going back to straight to the notebook, right back to the punishment zone. we're gonna deal with whatever shit we just got thrown our way here. It is not a gray image; it's a full frame. Yeah, just purchase for this. It's a good game though. It's a fun game. It's worth whatever like little money they're asking for it. It's like $2 or $3. It's definitely worth it. And it's also a great candidate, still, in my opinion, for that sort of work. Now, of course, are you going to get some difficulty out of it? Yeah, of course, it's not going to be like obvious and easy, but it's a good candidate in the terms that you. What's a good candidate, I guess, for Serpent.AI projects is how I should rephrase this. Any game that has relatively simple mechanics and not too many inputs is a good candidate, I would say. Like the simplest way to evaluate a candidate for if it's a good candidate to try and do something with the framework, right? Are you still considering a list of minimal? Yeah, of course, but I wouldn't probably need some help with that list, and I would probably need to play more games to detect which one is a good candidate or not. But it would be a cool thing. I guess maybe sometimes people are a little intimidated when they just look at the entire like Steam store and say like what's a good thing, right? But keep that in mind for now. Like if it has like not too many inputs, and if it's like the rules, or at least it could be like a part of a game. It doesn't have to be the entire games that have simple rules. Remember that Isaac, I didn't make it like explore the floors. I was just doing the boss fights. All right, so you can choose a subset of the game and use that as your environment too. Play more games. Yeah, no, nice excuse, right? Nice excuse. Kind of like game devs saying, "Oh yeah, I'm doing research," but they're just like playing the game. Is there a range of pixels? You guys are trying to just like get rid of some information. I don't think that's necessarily like the way I'm gonna go about it. I know what you're doing though. I could remove this, and then we're gonna do our threshold thing in a separate one. This is exactly entirely what I put in, right? I ended up putting in, and except that I finished this thing in the code that generated the side-by-side like comparisons of the threshold versus full frame. I'm just going to bring in the code for the thresholding from our project, right? So there's this that happens in the beginning before we do all the other stuff. I'm researching. I'm searching for bugs. Yes. All right, so black and white frame, let's just rename that. Oh no, shit, I don't want to rename that frame. God damn it. All right, it's black and white frame then. It is. And then it's not a game frame, not frame. It's actually just a frame. Like this. All right, so that's the current way we threshold. That's the current way we threshold. And everywhere I'm using frame, I need to use black and white frame. Anywhere else I'm using frame? Yes, here. I believe that's the rest. Quickly, yes, that appears to be, yeah. Okay, so that would be the np.zeros of the shape of our black and white frame. Oops. Chapeau, shapeau, with a D type of UN tape. Text versus not. Yeah, we could change the problem of the SVM. That's another good idea. Doesn't work for you. Aw. Yeah, no, we could totally change like the SVM and give it a different task. I agree. I agree with that. It's definitely something we could try. Right. Just like actual text versus garbage. But then I would probably have to. No, I mean we could throw it to the OCR. The problem is OCR will generally try really hard to assume that what you throw at it is text. Right? It's really hard to just like get it to say it's not text. So I don't know how far we could carry this. All right, so let's run black and white frame on this using the current and perhaps even do an SK image, although it's going to be hard to see the way it applies. So I'm trying to see why whatever is here is not getting detected. Text versus non-text. Yeah, I can see a lot of scenarios where this is just not going to pan out, man. So like I said, like how I might have to manually label, which sucks, or rely on OCR, which is gonna go full try hard mode on trying to give it associate it with a character that it shouldn't be associated with. So I don't know. All right, like this. Ha! Well, I guess I guess we have the reason as to why this was not already, right? Shouldn't need to. Yeah, that's the advantage of the SVM essentially, is that we don't need a ton of data to get somewhere. I still don't think like we're in a dead end here. It might seem like I'm just tweaking stuff and going back and forth, but not really. We're just like this is my problem. My threshold is too aggressive for this to even show up. Look at that, it's not even there. Right? Forget the garbage stuff for a while. It's not even there. Right? So, but if I go to 240, now the bigger stuff, the garbage is gonna be there. More, right? So there's more garbage, but we should see this if I save it. So let's also do an SK image. This new cryptocurrency, I don't follow crypto. I'm sorry, I know it's all the rage. I don't really like spend any time looking at crypto stuff. That's not saying crypto is shit. That's just I personally don't spend a lot of time looking at it. What happened? Im save. Let's just like whatever, man. Like we had name.png earlier. Let's just reuse that with black and white frame. I want to see that at this threshold, because that's what I'm treating right now is a totally separate problem. Totally separate problem. There you go. Now it shows up at least, right? So if you don't like what was happening before is that at 250, if I run this and I try to look at that name.png again, wait, it did show up, or is that like a cached version that Windows is just like showing me? It's a major snowstorm out there. That sucks so much, dude. I'm so tired of this winter. Aha! I see some disjointed candidates here. I'll have see now that's what happens. Is there's a disconnect in the pixels. It might seem like it's fine, but it's not. Right? It causes these things to not be like proper. I don't know if it's because of our like it creates like a density for edges that's not appropriate. So it still shows up sort of, but it's definitely not. Okay, wait. Versus a 240, if I zoom at the same level, I want to see if there's like if they're still disconnected or not. I think it's pretty obvious that they might not be. Yeah, see now they're connected, barely, but they're connected. And it's gonna make all the difference. It is gonna make all the difference in the end. So maybe we could use this, and now that we have a way to handle garbage, or we're getting better at handling garbage with that new code that wasn't there before, maybe it's acceptable to just drop the value for the threshold a little more. Just a little more. All right, so let's say I work with this, and then we apply the same rules, and in the end I'm looking for a clean frame where I just like make boxes around the candidates. Let's do clean frame where the region again. Now the first time I do this, I wish I would have kept it. Is equal to frame region. No, I said 255. Just make it full box. And then calm down, doggo. Jesus Christ. Hey, look at that. Now we have actual boxes around like all the digits, which was not the case because the one we got for, it's gonna be hard to find it again. I don't think I kept the full frame. I just kept, or I don't mean I kept I don't think I kept the non-full frame for this example. Might be a little hard to find where it came from. I'm not gonna try to do that. I mean, I kind of know what the number is, but it's gonna take too long. If we get lucky, but maybe if we get lucky. Oh, that's that one. And it used to detect this, right? It used to detect exactly this with post our little like experiment there, or little values. Now it detects the right numbers, but it also detects some artifacts. So we're not out of the woods, but at least like we're not missing out on actual valid input. Now we're getting this proper. That's like without a doubt, that's the digits. Like we know, right? We know for sure. Let's say I steal the saving as name.png on that clean frame, or just clean, whatever, on clean. I'll get it. Then I go back here and I try to, like compare both of them. Oh shit, is the other one in? Fuck off. All right, let's go out of there. Let's try to compare them side by side if we can, and we can. We will be able to do it. All right. So see, now the digits, at least we're detecting them, but now we just introduced some other artifacts. Now, if you want to visualize the artifacts, all I need to do, if you want to visualize them proper, not just have a box, is use the frame region instead of 255. And save that to disk. And then when we compare, holy shit, I have so many of these open. When I do this and that's cached. Too efficient. Stop being efficient like that. Stop it. See? Now we have the actual shapes. That's causing the issues. That's causing the issue. So that shape passes our tests and gets included in the data. And that's okay, nice. That's actually pretty interesting. We have pre-processing, right? So this is just after a threshold, a quick threshold. This is what I get. This is my frame. This is what I get after the threshold, and this is what I get after my cleanup. So I'm definitely cleaning up a bunch of garbage, but I'm not perfect yet at it. All right, so we do take out a lot of garbage, and while still keeping our digits, but it's not perfect. So we need to figure out something to make it even better. Anything that we notice here. I'm almost tempted to say, but then again, that might not be perfect. I'm almost tempted to say that the fact that it has like a very high white pixel density might be a tell. Anyone disagree? I think the only case where it would happen, or the height again, but that's a little unreliable, especially like in a case like this. Could you region the area divided by perimeter? So you just like add all the sides. So basically like y, the delta of the y and the x together times 2, and you divide the area by that. That's your ratio. I mean, I could try it. We could see if it gets rid of this. You mean as an additional one? I will assume. I think we can get rid of this. Like you guys probably enjoyed having that earlier, just to show like the detection thing. But it's always like in the way, so I'm gonna get rid of it. Okay, so where do we take this? Yeah, no, I know there. Oh, perimeter is already a property of region props. I didn't know that. I know area. I didn't know property. I didn't know perimeter. So I don't know what the check would be though. And would you do that on top of what we already have, or would you do it instead of what we have? I'm guessing on top. All right, so let's do if region area. I didn't know there was perimeter. That's actually pretty nice. Right, region. And then I need some sort of threshold. How would you threshold this? What makes sense? Like if it's too big. Nah, it's not too big, but it's oh oh oh, but the perimeter is not it's the perimeter of your bounding box, not of your white pixels. I think you're getting this one wrong. It's definitely going to give you the perimeter of your bounding box. So it's simply doing y1 minus y0 times 2. That's what it's doing. It's not the perimeter of your actual the area. I'd have to check, man. Like if the area is actually just the perimeter of, or the white pixels. I think the regions like actually map to a bounding box. I'm not exactly sure. I'd have to check the docs on this one. Kind of brings a good question. I should know this by heart, not assume that it works a certain way. So when we go at region props here. Yeah, she's mad at something. I don't know, dude. Just dog life. Oh, so it is the actual area. But we understand that the actual area is like perimeter is more impressive, but the actual area is just the count of white pixels. So that is not something that is that interesting. I am pretty sure if I compare area to the count of white pixels, it would But maybe then. Oh, there's way more than I thought inside of a region prop. That is very interesting. Number of pixels in the bounding box and versus the area, which is the number of pixel in the region itself. Hopefully they're not the same. And then you're talking about the perimeter. There's a ton. I know. So maybe we'll manage to make it work somehow. Perimeter, which approximates the contour as a line. This is good stuff. I don't know. I hope it's not expensive. And then you would be right. I agree with what you said. If that's the right perimeter, I would totally agree with you. Like a text would have a lot of perimeter per surface. Except for some. I mean, like just an L, for example, lowercase l might not have a lot of perimeter for the surface. Let's print out a couple of things. It's an interesting problem. I won't like it's fun. You can definitely spend a bunch of time on a problem like this. It's not meant to be solved like right away. I like the idea of the area and perimeter because it got me to learn about all these things. I was just always using the bounding box and the area, but never really like look at the other stuff. It's actually pretty interesting that there's all this in the region props. I think they're lazily evaluated. That's what scares me, to be honest, Josh. Like I think they're lazily evaluated, so I think that like some of them might be very expensive to run. Yeah. So just because something like looks good. Because I think technically behind the scenes, it just does like filters and measures and stuff like that, which are expensive. So it might just be like a nice starting point with lazily evaluated properties. Yeah. The ratio of pixels, that looks a lot like what I was doing already, just manually. I almost want to look at, because I think the area is an estimation. Let's try something here. Let's like just comment this out because I'm not really done with it. And let's try to print out for that region. Edges. Let's not do edges. Let's just print out region.area. Because I don't understand how they would complicate it more than that. I'm pretty sure it's equivalent. It has to be, man. Please. Please be equivalent, because that would be so weird otherwise. The black and white frame. Where, and then the dot size. And then I would say where black and white frame is equal to 255. What? No, but not the fucking frame. What am I doing? Jesus Christ. It's the frame where it's the frame region. Let's just print it one under. I got a little surprise there, but that's bullshit. Wait. See, frame region, that's gonna be perfect. I'm expecting to see the same number if I understand correctly their implementations. It's kind of bloated. As long as it's lazily evaluated, it's fine. I'm pretty sure they don't perform all these calculations. They might just be, some of them might just be aliases to others too. There we go. It is exactly the same thing. The way they determine the area is just counting the white pixels. It's exactly the same thing. All right, so that's I guess that's one thing to note. And here, what I meant is probably the size of the bounding box and not the actual area that's filled. Interesting. That's a good start. I think the perimeter might be a little costly to calculate, but I mean, we have our start. We have our starting frame with the threshold, and we have our expected result. So we just have to get there. Yeah. No, I know I would want the B box. So for the size, that's it. For the size, that's what you meant by this. It's the B box for this thing, right? Because you want the actual rectangle, and you're like, what's the amount of perimeter in that big rectangle, and not just like the white pixels, because that's not going to mean anything. So you're interested in the amount of perimeter per the area of the entire bounding box. That relationship you think is interesting to look at, if I understand correctly. I mean, since, like I said, since we know like that the expected result is just this and not that crap, we could definitely give it a try. And the area, if it's too big, that's essentially what I'm saying of a detected. Yeah, I think that's a good filter. It might be even less than that. I'm gonna print for every. Let's do that for every detected character. Let's print the area and see, because there's only 3 that matter here, and they might just be the smallest 3. Let's print the region area. To establish that, the reason I'm doing this is to establish the filter. Okay, so there's one that's 459, but it's clearly this blob that gets left over. That's 459. Everything else is rather small, including the other one that's bad or wrong. So I can definitely like bring this down by quite a bit and still be okay. So I don't know, like let's still like leave some wiggle room, because we never know. Like of course the non-score stuff. If I bring in some other frame, I'm always a little scared to just look override shit here. But if I bring this guy, of course now we have some valid candidates that are not. What's going on? What's the problem here? Invalid dimensions. Oh, because I didn't do as gray. Oh shit. Yeah, because we're starting from a color one. I'm trying to establish a good minimum area first. Like we have to do one thing at a time, really. Oh, come on, please. Invalid dimensions still. Is it as gray? Is it like this? No, it is. What? Oh, it's after this. Let's do it like this. I don't know why all of a sudden it's complaining about this stuff. Come on, dudes. It's a bunch of zeros. Well, that's not right. Ah, okay, I can't do it like that. Fuck. I know what's wrong. I can't do the of course I'm trying to threshold an already thresholded image. Okay, I'm getting distracted or tired here. I need to stop this. It's bullshit. Let's bring this guy back and without the S gray. So that's the full image. Oh, that's the other one. Perfect. And I'm missing the CMAP gray on this one. Where did that go? I don't know. There we go. This guy is the correct level, so this should be an easy job. There we go. So this level, like this image or this case, I can kind of move on already. Because look at that, we already have the perfect. Now with that lowered threshold, we're good. However, that was not the frame I was interested in. I was interested in the frame that was not in there. This one. Yeah, now we're back to our problem. Okay, so I just did all of this for nothing, essentially, because I want to make sure that I have a decent region for this, which I may not. I think the other way to do it would be I can't bring the other guys back in because they got captured at 250. They're not even valid anymore. They're not even valid. I can't use them. Anyways, let's assume this is fine, and then we'll tweak it if it doesn't work. I'd love to bring an image in there that has the awesome or the like the so close, because it would get me to at least like validate. It was a so close that we had. Fuck it. Fuck it. I'm adding another cell, and we're doing it. All right, I just have to treat it a little differently. That's all. Tis all. Tis all. All I need to do is bring it with skimage.io. Trying to collect my thoughts a bit here. Skimage.io dot imread on frame B, I think. Frame. Oh, it's in datasets. Datasets. Frame B. As gray. True. And if I work with this guy instead, I should get... I could kind of still show it. Yeah, okay. Because I'm interested in the size of these. And I know they'll come up first because of the ordering on the Y first and then X. So we have some 236. That's a little weird. It's not what I'm expecting. Oh, because I'm filtering on. Oh, shit. Let's bring it back to like a large number for now. That is pretty much the biggest we'll have it be. Like the biggest thing we'll encounter that's valid in this case would be this. The 600 something or 700 here, but that might be the biggest. Big ass. Now the big one is definitely like something ridiculous like this here. What's up, Slayer? All right, so the sensible approach here would be to do, if it's over 1,000, and just like keep it like that. That's it. All right, I wanted to validate this, and then we can start doing the perimeter area ratio, see if there's anything interesting to do with that. But I know for sure, at least now, that my area filter is adequate. All right, it's not going to filter out some good stuff. Now we're going to be left with smaller stuff. A bad programming joke. Well, why not? Why not? Okay, so let's say we keep working with... We go back to the old guy, this one, and work with this. All right, now we're back to our previous state. And it looks bad, but if we open the clean.png, it should be full. Yeah, there you go, 977. There's nothing. Oh, wow. Oh, my God. Oh, wow. So bad. All right, now all we're left with is these two things. Let's bring up the clean again, because it says clean, but it's not really. We still have these two, right? And I can kind of toggle the full frame versus the like the actual cleaned up version. So we're doing a good job, but we still have this and this here. Wow. Did you buy like a, like those cheap books in convenience stores when you kind of like fill up your car? All right, so how do we get rid of this boy and this here, these two? Because I'm still thinking the perimeter like approach is not gonna work that much with a candidate like this one, for example. Full ban. Another programming stream. Aye, yikes. Yikes. Like this one, Shotch. I'm just addressing Shotch again, because look at this shit, dude. Like, I don't think the perimeter thing is gonna work. It's gonna be able to filter out in this case here. Personally, I'm thinking that a bigger of my own creation. Shit, I'd rather hear that one, like, as at least then you can't say it's someone else's. Yeah. I do get what you were saying before. It's perimeter divided by white pixel count. Yeah, that's it, right? So it's technically perimeter divided by... Yeah, I think it's a better one too. I think it's like we had like both halves and we just like connected them together. Because I was focusing on I was focusing on the white pixel count, and you were focusing on the perimeter. But maybe like the actual solution is at the union of these two things. May very well just be. Ouch. Yikes again. Ow. I just lost some. I mean, it's good. You have to get started somewhere, but Doggo is a little not impressed. Ratios, man. It's all about the ratios. Yeah. It's transparent stripe detection with a kappa. Now I only bite for transparent stripe detection without a kappa. That's the one that matters. Let's try to bring in perimeter divided by area instead of the opposite, because the area is the count. I confirmed that the actual area is the count of white pixels. It's exactly the same thing. So it would be a perimeter. It would be a perimeter divided by area. So the opposite, the inverse, right? And then we need some sort of measure on that. We're going to need to establish a threshold. So before saying an if, maybe we should just like print out some measurements. And along perhaps with the bounding box to get a bit of an idea of what character or what bounding box it's associated to. And I should combine that together. We need to establish some baseline here, and we don't really have the numbers, so it's going to be hard. Gotta get that maximum performance. Don't distract me. We're already so deep in this thing. I don't need additional distractions right now. I think I think we can agree that we have enough distractions right now. So we're starting from, I believe we're starting from this guy, and I would start by removing the very large areas, but that would still leave us with some candidates before we do the whole. So maybe I need to do it after. I don't know. It's kind of really hard to identify like which one is which right now. But it's around the ones that are around like 700 height are the ones that are the good ones in this case. And they hover around 1. Nah, I don't think it's good enough, man. Just look at that. Like the other guys are still. Like this one, for example, the 299 is exactly in the same range as the right ones. And that's probably our, like, it's this big blob here. It's literally this guy. Yep, I think. I'm not sure. Might not be, but kind of looks like that. I mean, we could try. We could try to say like everything that's like between. I don't know. I think it's hard to come up with a legit answer. I don't think it's there. The solution's probably not there, man. I'm still a bit of a fan of using the actual perimeters. Well, we could definitely infer them, but if you want to see them. And perhaps to simplify even, I could do all of this after the processing that we were doing already. The reason for that is that at least we could focus on you know, like the perimeter, and only focus on the values that are still left after our current processing. Right? So it's these two that are problematic. And these are your perimeters. So no, actually nice. Nice. No, it works. It works. It sort of works. Like they are pretty far away from one another. We would need more examples, but after this processing, if we apply the perimeter ratio, so it's the other guys that got filtered out by whatever I was doing here with the Sobel, that got destroyed in doing this. But the real big ones should have been. That's what I don't get. They should have been skipped. There's no way that this like this block, for example, is under 1,000 pixels. I don't see it. You know, it's actually this big. It might not be the big ones. It might just be like the small like, little blotches here that still match. We could probably just do a minimum ratio too. Hmm. Look at that. I could do this and it would fix it for this one. Then we could probably take it for a spin again in me playing and capturing the stuff. But if I make a little additional and here and also say, let's say between, let's keep it really reasonable. So 0.8 would be smaller than the ratio itself, which we can get from here. And then, I don't know, what do we want to do, like 1.1? Or just like that it's greater than 0.8, perhaps? So there's enough complexity, technically. Like there's enough like lines going around in a small... Maybe I just need that this whole ratio is above 0.8 for it to matter. And I'm also scared that we would miss on some numbers because we didn't test it with all the digits. Didn't really test it above all the, like with all the digits, so it's gonna be hard to tell, man. Oh. Really? Really? We need more? Invalid syntax, that's a little weird. How is that an invalid character? Oh yeah, well I don't need the brackets if... Well, okay, shit. There you go. And then he gives us the proper thing, but that is likely overfitted to our current problem. I'm scared that if we get to use this now in, you know, like in the real world, it would not work out so well. The best would be to get rid of the candidates like some other way. That would be the best. So maybe establish a minimum. I'm still a fan of the minimum area thing. Right? So what's the minimum area? Like what's a number for the area that we're never gonna see that's valid? So let's say region, not area. Yeah, these really small ones. For sure. Like even a 12, I highly doubt it matters, man. Let's say I put in the bounding box too. Because I'm curious about the 12, 620 on the 12. Wow, I don't even see something that starts at 620. Is it this guy? Maybe it's this guy. But it's definitely some garbage. And then the 25 at 485. Oops, I need to look at the right one. That's this one. Yeah, no, so we can definitely do between. That's gonna reduce a few things. Is Doggo store bought or hand me down? Doggo is a rescue dog. I rescued her from the local shelter. She's not. I didn't buy her in a store. Less than 25. I would go like less than 100. No, fuck no. No. wait. Never mind. Well, that's the perimeter that I'm printing. I'll swap it with the area. That's gonna tell us. Oh shit. Never mind. Yeah, no, they're still very small. But we could remove some of the garbage easy that way. And then is it still useful to do this then? Yeah. Problem is we're always over. We can only try one test case at a time in the notebook. And every time we do that, we're kind of overfitting our solution to that specific case, and then we don't have a test set, right? It would be kind of nice to have a little test set that we can run through and have some sort of expectation. Maybe we should work on that, like making a smaller set of full frames, and then just apply this on that and see if all of our expectations. So it's kind of like unit testing with images that we would be doing, and we would have to do the assertions like manually by just like looking at it. Hmm. It looks like the scene from E.T. uh, yeah, I can't go like this is really borderline, man. Like, because this is a valid character. This is a valid character, and it's only 28. So I'm almost hesitating that I would put it at 25. We could do 10, and switch it like this. Oh shit, no, it would be the other way around. How does that work? I don't think this works even. It's the other way around. It would be 1,000 greater than this, greater than 10. Right? Or did I fuck up? I might have fucked up there. No, it's the other way. No, but that's not it. It skips the valid ones right now. I'm just fucking it up. I'm left with the opposite of what I want. So is it this then? Oops. What you're testing right now, we're still working with isolating the score without any other sort of interference from like full game frames, because there are some edge cases in levels like this one, where the background in some cases causes still gets triggered up with the score. It's a fine art, I would say, not necessarily like an entertaining one for some people in chat, but it's not easy, and it's kind of important for the experiment, right? Because if we have a shit reward function, and the reward function is a direct function of how well we can do this job here. If the reward function is crap, is not accurate, then the agent is not expected to learn anything correctly. Image unit testing. No, I know, man. I know. But it would sort of work. I would imagine this sort of work. Apparently, I can't do this one properly. So I'm not going to do the shorthand just because I don't feel like it. So I'm going to say if the region area is greater than 1,000, or like smaller or equal to 10. And I hope it actually saves one. If it's lazily evaluated, I hope it saves it so that it doesn't recompute it a second time. That would just be so stupid. And even 1,000 we said was kind of like beefy in this case. There we go. Now we're back to normal stuff. Then there's this big structure here. And that's one of the structures we were getting rid of with this code. And then when I print this, I'm left with just the score. All right, so do we build some sort of like corpus of images? Is that what we want to do? And then just like load them in and print out the results and mire them? I don't know. Because it's really hard to conclude that we're doing a good job. From, like I said, every time we bring in an image, we're improving, at least in theory, we're improving our detection, but then we're not testing the previous images to see if we're kind of like, just like, it's a bit of a scale, right? So I'm pulling in one direction and I'm thinking I'm balancing the scale, but I don't really know the effect on the other cases. So it's really hard. I'm going to bring in this guy because we have it at least, and then try to do the same operation on it and see what's result. Well, that did not work. That did not work. Oh, we'll do it the other way. So with this one, I think our perimeter ratio is not working at all. So see, that's exactly why we switch images, because like we just like pulled it in one direction and it's not gonna do it. No, it doesn't get there. It actually, nothing matches this thing. Nothing will match this thing right now. And if I bring this down, then we get some matches. And probably not enough. Yeah, we just get the score, but we don't get the other guys. Because this, the bigger the font, the more white pixels you have in there. So it needs to be a function of something else. Maybe the full air. I don't know, man. It doesn't work. This approach doesn't work. It only seemed like it worked for a specific font size. But it doesn't work with the large text, because the large text, the thicker fonts, they have more white pixels in them, right? They have more area. So it fucks up the ratios that we are kind of comparing over, like with. I would have to bring it down to values that make no sense for it to return what I want. SVM time? I don't think so. I don't think so. I'm still thinking in these. I'm still thinking that in these examples we're gonna see some. How do I say this, man? I'm still thinking that there's a way to take this out without the ratio thing. And I still like my ratio without perhaps the edge operators, because it was useful. I'm pretty sure I can take this out. But the right pixel count is being done on the Sobel here. It's so hard to not just like wanna, because my reflex here is to say, like, you know what, I'll figure this out on my own, right? But I don't feel like it's particularly like entertaining right now. But unless you find the actual prospect of me struggling so much and my brain melting like entertaining, which may very well be the case. But I'm kind of feel like I'm not reaching any sort of like I'm not getting any better here. Like we do have some progress, but there's always another edge case with another image that's not gonna work. And the SVM is too much of a different solution. Like I don't really feel like I should drop everything because we're so close. That's the thing. Maybe I'm falling into the the good old the sunk cost fallacy. I was looking for what I wanted to say here. The sunk cost fallacy. I'm like, I've invested so much time and we're so close that I don't want to like diverge from this. But there's something to this, man. There's something here that we can. You see, this whole thing without the perimeter like thingy was already working for this scenario. Okay, was already working for this scenario. We were already getting the correct data. So what I'm thinking, like, essentially, is that it will this will never, this doesn't look like a character, right? It just doesn't look like a character, and that's what you're telling me with the SVM. We could train it that this doesn't look like a character, and then I could just submit like the patch of white pixels against the dark background and say, you think it's a character or not? I could see that working. I just don't want to label stuff manually, and I still think, like I said earlier, that the OCR software will try its best to match this to a character. It's gonna say, "Hey, it's a comma," right? And then I'm like, all right, shit, because it's definitely will definitely try to say like it's a comma or something like that. If I pass it to OCR, right? OCR will do its best to match it to something. So I don't think the auto labeling would work, and the manual labeling would be, well, not on my top list of activities that I want to do today. So I'm thinking there's something to the structure of these. I'm just not seeing it there, but there's something of only 2 levels. It's not interesting work. It's not. And I don't know how many samples I would need to collect for it to make sense of the situation. Essentially, we would want to tell it it's a character. So what you're suggesting? Let's just like consider it for real. What you're suggesting is just like whatever. Keep doing the processing I'm doing now, and whatever's left, if anything, because in this case it's perfect. But that's what I don't like, man. That's what I don't like, Shotch. It's just that I would have to still not be. I would still not be sure that these are. If we take this approach, I would have to test each candidate here to make sure that it's. Oh, shit. And then the other approach that I was thinking of, perhaps, is. Well, closing is kind of out of the way. The other thing that was suggested earlier was also to look at the bounding boxes, namely the heights, but they're not like exactly the same, right? They're not exactly the same. So even if we sort by y0, okay, so it's 0, 0, 0, 0. Maybe we can go with with something totally different that's not an SVM and just like test the alignment of the characters, right? So for a specific character, do we have at least another character that's in line with that? I'm just not sure that's going to totally work. Yeah, no, I'm not sure it's going to work because see, the plus sign, for example, is the only one on its row. But it would still detect that there's at least one thing going on, and if it's just a score of 1, then it would yeah, no, it doesn't work. Like we're making assumptions that don't really pan out in every scenario, right? So it was suggested earlier to say, well, it's rarely going to be like a single thing, right? It's going to be like a group of things. So someone was suggesting, hey, if something's in the vicinity of another thing, another bounding box, then maybe we can go with that. But I don't know. Is it enough? Because see, this one is perfect. Oh, we solved the edge case for something like this. We didn't solve it like entirely, at least, for something like this here. Oh wait, I have another idea. Oh no, it's the same thing as before. Shit. No. 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 What am I trying to do? I'm trying to fix our stupid edge cases again with the score detection against like full frames from the game. So I'm trying to isolate only the score and only the score, and in like 95% of the cases, if not more, I get it. It's just fine. But then there's specific levels, specific edge cases, as is always the case, I would say, with programming stuff, where I get some garbage, right? Because of the way I'm using to isolate the score, generally does not clash with other things in the image data, but in this specific level, it does. So I'm trying to figure out like an additional set of processing operation, whatever, like little image processing operations that I can do to remove all the garbage, right? But I just thought of something else. Like, what if the area versus the bounding box area is over a certain threshold? Because look at the bounding box of this thing here. I don't think it's going to work in every scenario, but it would be worth a try. Let me try something. Peek. Yeah, no, bounding box versus... Yeah, I think that could work. Because I was not comparing it correctly. I was already doing a ratio with the white pixels earlier shots, right? But I was not what I was not doing is using the right one because I thought it was only area and that was the bounding box. But now if we do area divided by the bounding box area, that might be a little better because these will generally be somewhat rectangular or something like that, right? So they'll definitely be over some sort of yeah. Might be a stupid question. Does the game that need to know the score 24/7? We're not even looking at the digits here, Pagale. We're not even looking at the actual score. But I need to know that there is some scoring going on or a bonus like this here to reward the agent properly. All right, so that's what I'm really focusing on. If I make mistakes and I tell the agent that something bad is good or the opposite, then we're gonna have some. Well, we can't really possibly achieve. Like decent machine learning. Of course, like over a long period of time, maybe we could tolerate some errors. Yeah, exactly. The letters have a lot of unused space in the bounding box. That's where I'm thinking. Yeah. Exactly. So that is a bit of a little haha moment. Not the haha that you're thinking of on Twitch, but something else. Another aha moment, I should say. So I can keep this still, maybe, because my test here might just invalidate the need for this too. Because we're looking at edges, but maybe I don't need to do that anymore. And the other check would be and my region dot area divided by my region bounding box area. Is it B box area? Yeah, it is B box area. And that needs to be over, no, under a certain threshold for this to work. And then I don't know what the threshold is yet. It might be something like, like 0.75 to start with. Yeah. Get ahead up, but keep me posted. Yeah, I'll definitely keep an update. I'll be there tomorrow. Hopefully we don't spend the entire day tomorrow doing stuff like that again. I like the challenge. I don't like the seemingly lack of the seeming lack of progress. But I do like the challenge. I think it's an interesting challenge. But I hate feeling like I'm stuck on something for too long. All right, so let's bring back this example. This one is the current black and white frame, this thing, right? That's my input. And I'm trying to clean up everything that's not the score. Let's try this again. No, it's not going to work. I know already that's not going to work. No, it's still there. So maybe that ratio is still a little off. It means that the... Oh, shit, I said 75. Well, that would explain it. That would sort of explain it. It needs to be 0.75, not 75. It's a ratio. All right, please. Please, no, it still doesn't work. Can I do like 0.6? Nah, that's weird, man. Well, what are they then? So we'll remove this for now and print the actual ratio and see what's up. The area for sure has to be smaller than... It has to be. There's no way it's not. Region dot dbox area. Hey. Almost exited by accident here. Bbox area. How? No, that doesn't work. There's something that's fucked up here. Like, I'm getting exponent -5. That doesn't work at all. How is the B-box area so small? And it makes like no sense. There's no way it can be that small. Or it could be that big, I mean. Sorry, versus the area. The area is essentially the white pixel count in a bounding box. I don't even see how these ratios can be possible. And I can get rid of the perimeter ratio. We don't really need this anymore. So see, these are my ratios. All of them are like microscopic. Nah, that doesn't make sense, man. Because the area of the bounding box we already know. Like I said earlier, it's just like the the delta of the y's and the x's times 2 each, and then just the sum of that. So it's not, there's no way. No, that was the perimeter. No, the area is just like literally like the delta of the y times the delta of the x. And if I look at a structure like this thing here, I don't know why the ratio, that doesn't work, man. You say it's not so small. I don't know. I don't agree. If I just print out before the calculation, I print out the region, whoops, region dot b box area compared to y1 minus 0 y0 times, that's gonna have operator precedence. I can't say the word, so I have to. Well, I got some news here. This bounding box bullshit is totally fucked up. Doesn't seem to work at all. Because I'm doing for every region, and it tells me that the bounding box B box area is always the same fucking number, which makes no sense because that's probably that what? How do we even get something like this? Is that the full size of the image, maybe? The fuck is this? It almost feels like the full size of the entire image. Black and white image dot size. No? It's frame. Black and white frame. It is! This thing is totally broken. Piece of shit. It's like, oh, the region.bbox area. Oh, okay, let me just give you the fucking full frame size. Awesome. Good job. Nailed it. So I guess I'm gonna do my own calculation here and run with that. Because they can't be bothered doing this properly. Number of pixel of bounding box, but you're fucking full of shit. You're fucking full of shit. It's not. No, it's region. No. We're talking about a region. No, it's fine. It's fine, the Karki. It's fine. It's fine. It's the region out of stuff. Oh, no. We're fine. Oh, that was a scary. Oh, no. We're fine. Right? The regions are region props of label frame, which comes from the full frame. And the region has a bounding box. And I'm actually calculating the actual area manually. And I was getting 126, 667. When I use this ratio here, I get these retarded like values that make no sense, which is the size of the entire image. Well, okay, so we're just gonna roll out our own. That's fine. Never mind then. I'm gonna use my own here, and that's gonna be the ratio I'm expecting. There we go. Did I get it wrong still? The ratio should not be positive. Is the area also like garbage? I don't know at this point. You forgot what? Where? What? Where? Where did I forget the brackets? Ether blood. Are you just like joking that I forgot like it's a bracket that are divided? Oh yeah, operator precedence. You're right. I see it. Like the division is still taking precedence like over. Yeah. Absolutely. I see it now. Yes, finally. God damn. All right, now that's the ratio. That's the actual ratio. So much for having this. It's a piece of shit. Doesn't work. All right, cool. All right, what do I do with this now? Which ones are valid and which ones are not? That's the question. The two first ones are not valid. The two first ones are not valid, and then the other ones are fine. And it's gonna iterate in order of Y first and then X. So it's gonna be the two first ones that are bad, and they're pretty high, and that's what we were expecting, right? We were expecting something pretty high. I love how it's a specific subset of people that really enjoy this problem and stick around. Most people are just like, what the fuck is this black and white like image bullshit? Like, fuck that, I'm out. But then there's a specific set of people that are like, no, this problem is actually pretty awesome, and we need to solve it. Yeah, so it seems like high ratios, like I was saying, I was expecting. I just don't know what the threshold is, but maybe let's say 0.5 might be a little risky. 0.5 might be a little risky, but I could still start with 0.5, I guess. It might need to be adjusted. So before I do anything else, I could literally calculate my. Do I still need this? Is my question. Do I still need the Sobel after? Maybe we'll try without the Sobel, but I could say that the white pixel to area ratio. That's really, really specific, but especially when the other thing is called ratio. That is. Oh, I actually prefer to put it in here because it would not calculate it if this fails. Fuck it. We're gonna lose a little bit of readability, but. And if this is over, let's say 0.5, no, the other way around, under 0.5, because that's the valid stuff, then bye-bye. All right, and then print this guy. Yeah, there you go. All right. So now we need to do the other thing, which is test it against some other frames to see that this is not, like just like too specific to this thing. So I'm gonna bring in this other frame that causes this amount of like over detection, and let's try to run our current way to clean it up. Fuck! It's the same problem, man. The thicker font is the problem. The thicker font is the problem. It's not, it gets rid of all the other, the bigger letters. It's not, it should have been, but it's not. It should have been immune, but it's not. Maybe it's the 0.5, but I don't know. I don't think so. Let me just take that away. I thought no, I was gonna say I thought we had it. I know better than that. I know, I didn't know we had it. It was gonna fail again. We know that. It was expected. Show me my ratios. Oh, they're all fucking high, dudes. The ratios are super high, so this approach is not gonna work out once again. Unless I make them a function of their size. I mean, unless I make the threshold a function of the size, but that doesn't seem right either. The sound of pain and desperation. So now I'm filtering out my bigger letters, because if I draw a bounding box around this O, it is mostly white pixels. It is the white pixel ratio to bounding box area ratio right now. Count, sorry, I said ratio for white pixel. Let's try that again. The white pixel count to bounding box area, but that is still not. If it would have remained the same font size or thickness, we would have been fine. But they chose like a bolder font here, so yeah. And people wonder why I lose my hair and like grow a beard. Like this. This is why. This is why. Okay. Oh God, what's up, Mig? How? There has to be a solution, okay? There has to be a solution. Now, if you never see me live again, it's probably because I'm like writing on my walls or some shit and trying to figure out this thing. There is like of course like the whole like let's bring back like the SVM, that might be the next thing. Or maybe I just accept, you know, like in the end, here's my other idea. Maybe I just accept that. Maybe I just accept the little these things here, whatever you want to call them, and we just add like some checks on the bounding box's aspect ratio to make sure it's not too vertical or too horizontal, and then that would take care of some of the bad stuff. If you go back to our samples earlier, maybe I'll try to find something else. Shit. One that had like a lot of rectangles, perhaps, would have been a nice one. This is a pretty good one. I don't remember which one. It's 019. Do I still have a selection on it, or is Windows just like, nope, don't need that. We're gone. Oh, it's right here. So it's on this one that we get all of this good bullshit. And I see a ×2. And I don't know about you, chat. I don't see a score, but I could just be blind. I don't see a score. How can I have a ×2 unless it was just like fading away without a score? Feels like I'm going insane, man. I don't see it, but it looks like this is the only relevant part in this frame. Might be a good test case too. I don't know why we have a multiplier without a score. That seems wrong, but so this might be a good candidate to test too. A lot of garbage. And is that where the score is? No, it's not. So we have a rectangle about here. We have some stuff that's too bright around there. I don't know. I think I'm gonna give up for today. It's been more than 4 hours. I think I'm just gonna try to work on this on my own now. It's very clear that we're kind of like not having a lot of momentum right now. Kind of stuck with this stupid problem. So I don't know. Yeah, I'm gonna try to work on this on my own. I think that's the correct call at this point. I'll be back tomorrow. I hope you're not gonna be insulted if I try to solve this on my own, and I will share the solution for sure. If I do come across a solution, I'll be sure to share it next time, like tomorrow when I start, right? Because this is starting to drive me a little insane. I have to admit defeat at the right point and not just keep going, and I'll try to use frames like these and try to clean them up some more. But I don't see it right now. I don't see like an exit or we've made progress, yes, but there's still concessions that are being made. there's still stuff that gets included that should not be there, and that might greatly affect, you know, like the results in the end. So we'll see then. You better have a solution tomorrow. Oh well, I probably won't sleep very well if I don't find a solution. I'll tell you that. But you can probably tell that you know, like the fire, the passion is not even in my voice anymore, because we've tried a lot of ideas of solutions, and they always sort of work for a specific like a specific frame, but then they kind of like offset something else. God damn it. Jason M. What's going on, my dude? Thank you for the host. I was about to call it. I was about to call it. Like, it's a little awkward, but thank you very much, Jason. Jason also part of the Brain Bites, folks. My brain is dead, Jason, man. Like, it's melted. I have a problem right now that I'm working on, and along with chat, not just me. And we can't seem to solve it, right? We can't seem to solve it. All right. I just called it too. I can't. Like, I'm sorry. I can't. I guess I could show you. I could show the people coming over from your stream like our random agent. That would be a fun thing to watch. Because I'm currently working on building some sort of machine learning model that can that's gonna be able to kind of like learn over a period of time by just like trying to play this thing. So there's no analysis or anything that's performed. It's just gonna be, it's just gonna look at its environment, try things, and learn to play the game. So I could show you what we have right now. It's a little random. Yeah, can we watch the random agent for at least 5 minutes? All right. That's the only thing that's gonna put back a smile on my face at this point. So I'd rather, let's just watch it for a second. What's up, Doggle? Doggle wants to go outside too. So see, it's a good time to call it. Maybe that can be the closing credits for today. I need to regain some sanity somehow. It shouldn't be this hard. I know. It's always like this, but there you go. So this is the game. The game is called Super Flight, and you're pretty much like a low polygon wingsuit person at the top of a randomly or procedurally generated level, and your goal is to accumulate score, right? So how do you get score? You get score by flying close to the random structures. Like the closer you get, the more risky you play, sort of. The more score you'll get. Have you heard of Super Hexagon? Super Hexagon was probably the first game I ever worked on it. It was not a machine learning approach though, Jason. So, but yes, I have heard of it. I would also be really, really curious to try it back again in the current state of things. Yeah. Thanks for recommending, Jason. Nice. No problem, Uncle Bill. Today has been an interesting day here. I have not managed to solve my number one problem, so I'm a little disappointed, a little frustrated right now. It's still in a better place than it was, but not there yet. Not there yet. So this is the random one, but essentially like we have all the pieces to get it to interact with the game. So I kind of told you guys like what the general idea of the game is. So now what I'm trying to do is try to build a reward function for the agent based on the score that's accumulating on the screen, and if it gets like a multiplier or a bonus or something like that, I'm trying to isolate that from the background in real time. I don't care for the numbers or the digits themselves, and I already have an approach that works in, let's say, around like 95% of the cases. So that's not the issue. But there is a specific level. or set of levels. They're random again, and everything's random. The color schemes, like the actual layout of the structures, everything's random. But there is a case where the sky or the fog is almost like a pure white, and that clashes with my technique of isolating the score from the screen. And we've been trying all sorts of approaches and still can't really like when we fix it for a specific frame or use case, we fuck it up for something else essentially. And I've been going back and forth between fixing a frame and breaking another one. But yeah, no, once I have that, the reason I'm spending so much time on this is that's going to drive the reward and punishment system for the agent. So these techniques, they're called like reinforcement learning. So it's going to be an agent that knows what inputs and can press, and this is kind of like where the random agent comes in, because we can kind of define an input space like I'm doing right now, and it's going to pick something from there. And when it does something, when it tries something in the environment, we call that like exploring the environment. It's going to have a visual context. It's going to have like a key that it presses, or some actions that it picks, and then it has to see like on the frame after. If something good or bad happened, it needs to get told, because that's the state of our, like AI stuff right now. I mean, and I don't mean as me and my framework, but rather like as humans. We still need some sort of like manual input. We need to tell it, hey, you did good or bad, right? We're basically like mommy and daddy or coach. I need to tell it like, hey, you did good or bad. So I need to work on that. I need to craft this reward function, and we work only from visual data. So I have to infer my reward or my punishment from a series of frames. And the way I chose to do to do it right now is to try to detect when we're scoring, first of all. If we're not scoring, we're going to give it a slight punishment. If we're dying or dead, we're going to give it a punishment. If we are scoring a little bit, then it's some sort of a reward. If we're scoring and we're getting a multiplier, a little bit of a bigger reward. And if we're getting a bonus because we just did something. Because if you fly close to structures or you fly in little like enclosed spaces, you will get some sort of like one-time bonus. I would give it like a max score if it gets a bonus, and it is scoring right now, right? So getting there, like the actual machine learning is well, it's gonna be different. It's gonna be new, but I need like everything kind of like depends on getting that reward function right. It's a little difficult to infer it from frames at least, right? From visual data only, I need to decide if I want to reward or punish my agent. So yeah, that's been the ongoing problem. I can show you the level if I stop this guy. If I stop this guy for a sec, I can show you the level that causes the issue. Like a level like this, right? Where look at the background. Look at the background here. It's not necessarily the contrast between the score and the background, because you might not see it very well here. When I am scoring, you might not see it very well, but I can still tell it apart. It's just that some other stuff in the background will kind of like get caught in my thresholding, and I'm trying to get rid of the artifacts. And still haven't really solved it by today, so that's where I was at. That's where I'm going with this, and I'm gonna try to solve it like with dinner and you know, like perhaps like an adult beverage tonight or something like that. I'm gonna try to solve the issue, try to come up with something that works in most cases. But no, so far, I mean, like it's doing a good job at isolating. I could run this with the current logic. Let's say I don't want to get rid of the frames, but I could try to show you guys something before I call it for today. One last thing. I could go on some, you know, like random map. Oh wow, beautiful map. All right, and I'm gonna play it with the regular agent and not the random agent. So if I play with the regular agent right now, I'm gonna be saving what I get out of the thresholding, and you'll be able to see perhaps like the problem. Adult beverages, yes, they do. All right. So you just saw the other level. You can kind of get an idea of like how it generates its level. So let's say it has different features. Sometimes it's like angles, like little, you know, like prisms or pyramids and something like that. Sometimes it's like columns. Sometimes it's just like squares. And but essentially, like I'm playing right now, this is a funky one. I tell you that. Ouch. I'll just accumulate some score, and behind the scenes right now in this mode, and I'm controlling that. It's not like an automatic thing. I'm saving the thresholded versions of the frames, and you'll see that in this level, for the most part, it should be like very, very good results that I'm getting. So I'm still trying to solve it for that specific level or set of levels where the background is like a pure white, and it's been a challenge for sure. So see, now I'm accumulating score. I got a multiplier. I would have to do something kind of crazy to get to get like the other bonus stuff. But if I were to stop playing right now, I'm just gonna try to get something. No, you don't want to reward me for no. Okay. All right, fuck it. I'm just gonna stop. And if I look at my folder called in my data sets for my Serpent stuff, at the bottom here, we should have some new stuff. And then this is essentially what it saw versus what it got or it identified, I think. Yeah, in this case. It's still not fixed because I'm applying something. This is not the latest version. I'm just kind of showing the boxes where I do have a score, and you can kind of see that it does match roughly. All right, so for these levels, I don't have a lot of issues. I can kind of match them pretty well. It's really just the other level right now, and it's been driving me a little insane, to be super fair. And I think Chad has experienced that today. They've seen me be increasingly like discouraged / annoyed. So that's it. Like I have to take a break. I have to get some fresh air or something. I have to take a break from this thing. I'll have some dinner, and I'll just, you know, like maybe just like watch a dumb TV show for 30 minutes and then try to crack this thing again. But that is in essence the problem. That is also the project I'm working on, right? So if I take myself out of the now, I'm trying to really get something working. So there's a good chance that on my channel in the near future, you'll see something that's kind of like on autopilot. All right, you might have some chill music and a machine learning agent trying to learn to play this game as it plays it, right? So it discovers the environment, it tries things, it gets told like you're doing good or you're getting bad, or you're doing something that's bad. And over time, perhaps a long, like a very, a very considerable amount of time, right? You'll see it like hopefully get better, right? So it's kind of something that's going to run like 24/7. My brain is dead. See, that's why I can't even speak. It's over. Like today's GG, man. But yeah, no, it's gonna run like for pretty much like an entire week, 24/7, and you can just like kind of check in once in a while, and you'll see like the progress of the experiment. Oh. All right, I'm dead. I'm dead, chat. I have to just say, like that's it. I have to say that's it. I'll be on tomorrow, and I hope I have this figured out. Hopefully, if you don't see me tomorrow, I might have just like, like rage quitted the entire thing. uh, but yeah, that's gonna be it for now, man. Thank you for joining, and have a good next AI. Exactly, Ramsey. Let's go. We're gonna get there. We're gonna get there. I'm definitely looking to emulate the same sort of stuff we've done in the past, but with this game, it should be fun. Should be fun. All right. So have a good one. Have a good, have a good rest of your evening, or sleep well if you're about to go to sleep. I'll be on tomorrow, hopefully with good news and a smile on my face and renewed renewed happiness or something. All right. So you have a good time, Chet. Thanks for joining. I'll see you tomorrow. I'll give you doggo as I go out. Okay. All right. Have a good one.